IEB Mathematics Paper 2 November 2020 final exam. Would you look at that? Would you look at that? This is legit like the first IEB paper on the channel. But then the one thing I can say up front is that IEB papers are like 100% suitable for like both IEB students and CAPS learners, vice versa. You see, like even a person doing like IEB, right, they are basically able to practice using like CAPS papers. So don't be that guy that says, oh no, it's IEB, I can't go through it, or oh no, it's CAPS, I can't go through it. Nah. You are just depriving yourself of some good practices, because literally the only thing that differs is like the format, the format of like literally like how the questions are like set up. Like now you see question 1 is not necessarily statistics, whereas in CAPS question 1 would have been like statistics, but it's the same idea. You see, you still have the same syllabus, you still have the same style of assessment. Don't put yourself in a situation where you think that going through IEB papers is a waste of time, or going through CAPS papers is a waste of time if you like are an IEB student or something like that. You see, okay, just be humble and do both syllabuses. You will not regret it. But anyways, I don't think I need to give a whole speech. You were the one thing I just noticed. Okay, let me just actually start before I like start, just wasting people's time. So anyways, I think the one thing I always forget to do is to introduce myself in the beginning of the videos. Me is Levi from Bright Young Brains. Oh, there's Bright Young Brains right over here. Oh yeah. Hi guys, Levi here from Bright Young Brains. Is how I usually start like all my videos on like my main channel. But anyways, let's see here. Question 1 in section A, right? It says here for 3 marks, determine the value. Okay, we're given this, and that, and they said here they're on the same straight line. So if points on the same straight line, it means that the gradient from one line to the other is like exactly the same, you see. So with this being given, they said we should get a value for A. So the good news is we can just get the gradient of like QR, and then after getting the gradient of QR, we can use that to get the value of A here by putting P and Q into the gradient equation, or even just P and R. It really doesn't matter. So the gradient equation, we know that it's just y2 minus y1 x2 minus x1, nothing crazy, nothing major. And then what else? Oh yeah, we need to throw in the values. So let me just make sure here that I don't waste my space, because me's got to be careful. Let's see here, y2, wait, what do I do? Oh yeah, let's label this x1 y1, x2 y2, so as we don't get confused. So let's see here, we're going to have here 8 minus 4, the whole thing over 1 plus 3, because you see 1 minus negative 3 gives you a plus. And then at the top you have like a 4, at the bottom you have like a 4, so the gradient here is like a 1, you see. So what that means is the gradient is a 1 for P and Q. You see, if you're going to work out the gradient between P and Q, the gradient is a 1, of which you can say here y2 minus y1, so it's going to be A minus 4, and then here 2 minus the negative 3, which is going to be 2 plus the 3. And then what you're getting here, this is like, you see, A minus 4 at the top, and then you get like a 5 at the bottom. And then obviously here, because we want to get A on its own, we can just multiply by 5 on both sides, you see. Multiplied by 5, multiplied by 5. This is going to give us A minus 4. Whoa, bro, what is going on? A minus 4. So this being A minus 4, we know that you can just work out A by throwing in the 4 to the other side. This is giving you a 9. So obviously a 9 doesn't seem like the best of answers, but I mean, like, it is what it is, we're getting a 9, so you don't want to fight it. You don't want to fight it. So we're just going to move on to the next question. So the one thing I can say up front before we move on to the next question is, if you check in the description, right, you will see that there is like really nice timestamps there. timestamps that will take you exactly to the question that you need to go to without even worrying about anything. So yeah, man, make use of the timestamps, you know what I'm saying? Question number B. Number B. Ah, my guy, is it number B or just B? Well, here it says S and T are joined by a straight line. Determine the equation of a line that is perpendicular to ST and goes through the midpoint of ST. So you can see this is a whole IEB paper, but look at the kind of questions they're asking. You see, normal questions. So if you are a student that is like doing caps, you see, normal questions, nothing crazy, nothing major. So because we're asked for the equation of a straight line, the point here is before we worry about this straight line being perpendicular to the line that goes through ST, what we just need to think to ourselves is that the equation of a straight line, it is just y is equal to mx plus c. The reason why they are saying that this straight line is perpendicular to a line ST, it means that they want us to use ST to get the gradient of the line that we're referring to. Because the gradient of ST, right, if we get it, we just need to multiply it with the gradient of the line that we're dealing with now. This gradient will be, this value will be equal to -1. If we say the gradient of ST minus our gradient right now, we know that it should equal to -1 because the lines are perpendicular. Whew, I was legit yawning there. Yawning and speaking at the same time. What a wow. Anyway, so let's get the gradient of ST. So getting the gradient of ST, I mean like gradient formula shandies. Nothing crazy, nothing major. So let's do here x1, y1, x2, y2. So we got here 6 minus 8. And then you got the -2 minus 4. And then here, what does this give us? This is like what? -2 at the top. And then we've got -6 at the bottom. This is giving us a third, you see. So here we can then say, therefore, a third, if you multiply it by m here, this should give you a -1. If you divide by a third on both sides, you can see here that we are getting the value -3. Nice, nice. Now, most people would argue that you have to like write out the formula for the gradient always before you use it. Well, I mean, like, really doesn't hurt. It's on the formula sheet anyway, so might as well write it out, you know, just for the vibe. It's like legit. So we've got the gradient here. It's like -3. So far we know that our straight line graph, it is having a gradient of like -3. But then apart from that, for us to get the y intercept, so far this is what we have, right? Our m, we know it's like a -3, so we have like -3 here, and then x minus x1. This equation gives you a straight line graph equation if you throw in one coordinate that the graph passes through. So before we can use this equation, we have to use the midpoint formula, because yeah, you see, so here we can say midpoint, let's say here midpoint of ST. The midpoint of ST is clearly just going to be x1 plus x2, and then here, yo, ran out of space, ran out of the space so fast, like so fast. The word fast is so weird when you say it like fast. It's weird. Or is it? Or is it just me that's being weird? I guess we'll never know. So anyways, this is y1 and y2. This is going to give you the midpoint of ST, you see. So likely with ST, I mean like what their values here. 4 plus the -2 is just like 4 minus a 2. And then you've got over there 8 plus 6 mental math, mental mathematics. We've got like a 14 and then a 2 at the bottom, you see. So the lucky thing is here we just have 4 minus 2, which is like a 2 over 2. And then here this is like a 7. So this is our coordinate, you see. And then here we can say therefore, so in our equation here of the straight line, we can throw in this coordinate. This coordinate you can clearly see, we can label it x1, you can label it y1. So here we're going to have y minus the 7 is equal to -3. And then the x value is like a 1. Oh, no. Where x is, we just put x. Where x1 is where you put like the -1 there. And then here you just want to simplify. You see, the y stays on its own. These, you would multiply them inside. So you'd have like a +3 there. Ooh, Forgot the x, my bro. Forget the x. No, forgot it, not forget it. You forgot it. So put it back there. So this is going to give you a positive 3. And then when this comes over, it's like a positive 7. And would you look at that? You'd have got the answer. Very simple stuff, this. And I think throughout the whole paper, right, I'm literally going to be saying, if you're a kept student, look, you see, normal paper. Because, I mean, I'm assuming if you're an IEB student watching this, I mean, I'm not trying to badmouth you or anything, but let's be honest, there's nothing special about IEB, really. It's just a different syllabus, so it is what it is. Yeah, I hope I don't get hate for that, but it's just facts, it's just facts. Let's be honest. Let's not, yeah. Oh lol, oops, that sounded so deep. But it's really not. If you're doing IEB, like, trust me, I'm not trying to be mean or anything. Oh goodness, yeah, I'm just saying it like it is, man. But I feel like you're woke and I'm telling the truth. But anyways, let's see. See here says in the diagram below, CBA. Where is CBA? CBA is drawn with C on the y-axis. Yes, C is on the y-axis. So it looks like here we're doing some analytical geometry. Well, it looks like we've been doing analytical geometry, which is just, what IB is, you see. Just a different format in terms of the papers, but it's still the same syllabus. So here, CBA, right, is drawn with C, yes, on the y-axis, and A on the x-axis. Okay, very nice. Then it says here point D is 6 coordinate 1. We can see that. So obviously, as you can see, if you're reading a description, don't read it like you're reading a paragraph, because most of the time whenever I make someone read a question, like while going through like a Zoom session or whatever, they just read it like a paragraph, and then I'm like, no, you want to read and always refer to the sketch, you see. So here it says this lies on the line CA. Then we have point E, which is this. Okay, fine. These look like they're parallel. We don't know, but I mean, like, making the assumption is not something we can do until actually proven. So let's see here. With all this being said, they have given us the equation of AB. Where is AB? They gave us the equation of AB, you see. It's just not in standard form. And then they gave us the equation of like CB. Where is CB? Oh, there it is. It's just not in standard form. So to be honest, putting these equations in standard form is the best thing that you can do for yourself, you see, because it's also going to be on your answer sheet anyway. So let's see here. Putting this in standard form, you may be asking yourself, do you want to do it right from the get-go, or do you want to do it like later on? Well, on your answer sheet, you can just make it the subject of the formula immediately, like, So here, let's see. Making y the subject of the formula, it's quite easy. Everything goes over to the other side. You're going to have 2x as a positive with a negative 24. Same here, you see. Here, you're just going to divide both sides by the 7 there. Then you're going to have, let's put 1 over 7 with the x, and then plus a 2 there. The reason I'm putting 1 over 7 here is because there's a 1 in front of the x here. This one, you're going to divide it by a 7. You see? Fantastic. Question, this one here, it's for 3 marks. They want us to prove that ED and BA or AB are parallel, you see. We said they looked parallel, you see. So now we're about to prove that they're actually parallel. And the good news is the moment we prove that they're parallel, we know that, I mean, like, they are definitely parallel. You know what I'm saying? So let us keep that in the mind. You see that if these are parallel, then, I mean, like, this is what I always say. If you're going to prove that something is parallel, just think of the blunt things. If these are parallel, then you're going to just need to prove that this is equal to this, or you're going to have to prove that this is equal to this. What else can you prove? Yeah, whichever way, whatever you do, just keep in mind that you have many options of proving that this is parallel. Well, this is a 3-mark question, so you really don't want to panic too much. Now, I'm busy blabbing and saying all that I'm saying, but I'm literally just sitting here and thinking to myself, how do we prove that these are parallel? Well, the lucky thing is, the one thing I just spotted while thinking that is that this line here, the whole thing is given. There's a coordinate down here, there's a coordinate up there. So we can get the gradient of ED. Because if we get the gradient of ED, we just have to compare it to the gradient of like line AB, of which the gradient of line AB, according to this being in standard form, we know that this gradient here is like a positive 2. So if we can show that this is positive 2, we're good to go. So you see, putting this in standard form kind of helped us, because now we can safely say this, you see, because we've put this in standard form. So our task is to just prove that the gradient of ED is a 2 as well. So let's see here. Gradient E of the D is equal to y2 minus y1, x2 minus x1. You see, very simple things here. Well, likely, like with your paper 2's name, yeah, I mean, like warming up is good, you know, warming up is like real good. So here we can just say 3 minus the 1 there, it really doesn't matter, and then 7 minus the 6 there. 7 minus the 6 there. Let's see if we're going to get a 2 here. Ooh, let's see, 2 at the top. Oh. 1 at the bottom. Nice, man. Nice, man. Nice. You see, therefore, the gradient of AD is equal to the gradient of AB. You see, therefore, E the D is parallel to A the B. I mean, like, so clean, right? So clean, so neat, so nice. We love to see it. Nothing crazy here. This question is not difficult. That's how we're going to blaze through it. For 4 marks, 2, it's saying if D is the midpoint of CA, then determine the coordinates of B. If D is the midpoint of CA, where is D now? Wow, man. Then determine the coordinates of B. You see, these questions, they're so simple. Or are they? Ha 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 ha. Well, I hope so. Well, they said here, if D is the midpoint of CA, yes. So the only thing that they're trying to tell us is that this is equal to this. And then for only 4 marks. So 4 marks is a question that does require you to do some form of thinking, you see. So for 4 marks, they said we should determine the coordinates of B. So where is B now? B is like right over here. Okay, this is okay. This is okay. Not a problem at all. Not a problem at all. Let's see here. Got a B here. Make this B look nice. Oh, why am I wasting time making that B look nice? Hey, okay, to be honest, I think I'm legit like just stalling. But this one is quite a simple question. The only annoying thing is they are telling us that CA has a midpoint of D. That's like almost trying to throw us off, because I mean, like, we have the equation of CB anyways, and we have the coordinate equation of like AB. So we can just work out the point where they meet, you know. So this being the midpoint is absolutely nonsense. Like in this case, it's so much garbage, because we don't even need to know that right now. But hey, let me not sound like a person that's like angry and like is like, like strict. Like, no, I'm just like, why are you telling us this right now? We really don't need it. But anyways, let me just work out where these two lines meet. You see, where these two lines meet is all that we need to work on, you see. So let me just copy these two lines, you saw. They are equations, because that's practically all we need. We're just going to equate these two lines here. So let me copy this. Let me put this here. Let me paste this over here. Make sure I have enough space so that I don't, you know, run out of the space. So here we know y is equal to y, which means that 2x minus 24 is equal to 1 over 7x plus 2. Now, the ones with x, we can take it to one side. You see, 2x minus 1 over 7x. And then this is like 2 plus 24. And then this here is like 20 the 3. Hey, no, 26. Oh, good. I said 3, but I wrote a 6. Wow, man, flex. Anyways, stuff like this, me, I always just put that in the calculator, you see, because me, I don't want to make dumb mistakes, me. Making dumb, silly mistakes, it's sad, eh? It's so sad when you know your calculator could have just given you the right answer. This is 13 over 7x. So let's just put here 13 over 7x. And guess what? Yes, I am definitely going to just divide by 13 over 7 on this side here. Ka-ching, ka-ching. And then here 13 over 7. Very nice, very nice. So what do we get for x here? What do we get for x? Tell us the answer. Tell us right now. So in the calculator, if you put all that there, we are getting the, let's see here. Well, the funny thing here, you may be thinking to yourself, is there a way we could have used the proportionality theorem? Well, one or the other. I mean, like, you probably could have, but like, that's just some, yeah, that's just like some, yeah, in my opinion, I mean, like, just do what you think is easiest, you know, because like, yeah, there definitely is some funny proportionality where you could do this, but not akirikeni. Anyways, x here is going to give you a 14. So the y value, we know that we can just throw in 14 into one of the equations. Let's throw it into this one here. 1/7. Throw 14 over there. Y value is like a 4. This is nice. This is so nice. So we know that therefore b, we have 14 and we have 4. Fantastic. We love to see it. Let us move on. 3 is where we are at, people. 3. So the timestamps for this, yeah, they're going to be quite strange, but we made them work. Shout out to, you know, who it is, Sumaya or Alisa Diatul. I don't know who did this one. Oh no, shout out to Sumaya. Like, you should say thank you, Sumaya, for like setting up the timestamps. Like, yeah, it says calculate the size of CBA. What is CBA? Oh, this angle here. Well, don't forget anything that you have worked out. You see, anything that you have worked out, I mean, like, cherish it, you know, cherish it. Try and remember how you worked hard to get it, you know. This is equal, and we have the equation of this line, and we know that, no, we don't have the equation of this line. All we know is it is parallel to this one. We have the equation of this long line, and we have the equation of that one. So they said we should calculate the angle here. Yeah. So rule of thumb, if you're ever going to need to work out an angle of a sketch in, like, you know, on a Cartesian plane, always start off with things like the angle at the x-axis. That's going to be your best bet. If you can get the angle at the x-axis, you're gonna be in a better spot than if you just think that you should just do things randomly. So the good news is we have the equation of this line in particular. So this is where I would start, to be honest. This is where I would start. So we just want to map out some kind of a plan, you see, in the sense that, for example, if you're looking at what we have over here, so what happens if we get this angle? Yeah, let's just brainstorm and see. If we get this angle, then what? Excuse me. I just yawned so long. For so long, I just yawned. But I mean, like, put the blunt things, okay? Like, just put the blunt things. Don't be shy. So if you look at this question, right, it is a 5-mark question. So for this 5-mark question, I'm going to show you a trick. So the trick that I'm going to show you is something that is very, very examinable, something that is definitely going to give you marks, you see, because likely this is going to be on your answer sheet. So all these constructions, you see, they'll be able to see them. So what you can do for yourself is extend this line over here, you see, extend this line over here. And what you want to do is, you see your x-axis over here, you want to map out the x-axis somewhere up there. You see, this line here, you want to make it somewhat represent the x-axis. You see, this line over here, let's change style. Let's maybe make it white. There we go. So this line here, right, you want to make it represent the x-axis. So the reason why I'm saying you want to make it represent the x-axis is because whatever we're going to do, what we actually just need is a line that is parallel to the x-axis for us to use the tan formula. You see, the formula that says the gradient is equal to tan theta. So this line here, we know that, I'm using a different color. Use a different color, my bro. This line here is parallel to the x-axis. So what we're going to do is we're going to use the gradients of two lines. I mean, like, if you look nicely, we're going to use the gradient of two lines here. The lines that we're going to use is AB and CB. You see, because if you look at CB extended, this is the line that is formed there. You see, so what we're going to do is, using our tan formula, we can easily find this whole angle over here. You see, this whole angle, we can find it using the tan formula. And then this whole angle over here, where is this angle? This angle over here, we can find it using the tan formula as well. And then we'll be able to say the big one minus the small one is going to give us the green piece over there, of which if you look at the green piece over here, this green piece is the vertical opposite to this green piece over there. So just looking at it like this, you may think it's like complicated or not, or you maybe think to yourself, oh yeah, we can definitely do that, which is both good. Because I mean, like, all we have to do is you have to remember that don't be too scared to put things onto your sketch, especially if they are valid. You see, me putting this horizontal line over here, this horizontal line here is mimicking the x-axis. You see, it's just like how the x-axis behaves, so that you can get the pink angle and so that you can get the red angle over there. I'm yawning. Why am I yawning? Yawning is not good, eh? Not at this time, maybe. We've got a long way to go, man. You can't just be yawning right now. So let's get the red one and the pink one and use that to get other green ones. So let's just use our 10 formulas here. It's just the 10 formulas all the way. So the gradient of CB. If you look at CB, I mean, like, let's see what we had for CB. See here, right in the beginning, we made CB. We made thingy the subject of the formula. So we have like 1/7 as the gradient of the line CB. So let me just put it here so that I can remember it. So the gradient of this line over here, we know that it is 1/7. You see, that's the gradient of this line here. Or rather, I hope I'm not making a mistake. Am I? No, I'm not. So here we know that the gradient of CB is equal to 1/7. The gradient of this other line over here, this line here, this is the line AB. AB. We know that it is equal to 2. You see, that's the gradient of AB over there. So this being the gradient of AB, let's see. Let's use that in our formulas, you see. So in your 10 formula, don't overthink this 10 formula here. This 10 formula is a friend, you see. So we can just even put a random symbol here. Let's put alpha. You see, this here we know it is equal to, let's make it equal to the gradient of AB. You see. So if we make this equal to 2, then we can say here 10 alpha. And then here we can say alpha shift 10 with a -2. Let us see what this gives us in the calculator, okay? Like shift 10 with a 2, this is giving us a whopping 63.43%. So that's okay. 63.43%. Did I just say percent? I meant degrees. Boso. Where's the percent coming from? So you see, we've gotten which angle now? We've clearly gotten the pink one. You see, 63. Because we used no, bro, no. Why are you confusing the people? We have gotten, we were using the gradient 2, right? So it means we got the red, the red gradient there. You see, the red gradient is what we got. So let me just actually make this line here red. So the whole red gradient here, we've gotten it to be 63.43, like that. You see. So let's get the pink one. The pink one, how do we get the pink one? Now the pink one, we use the 1/7 there. So here we're gonna have 10. Let's call it theta, this one. And then we're gonna put 1/7 as the gradient. Now theta is gonna be equal to shift 10 with 1/7. Let's put all this into the calculator. Shift 10, 1/7. Let's do, that's just like 8.13, which kind of makes sense because yeah, you see, it's just a small angle there. 8.13, which kind of makes sense. So here we can then say, therefore, the green one, you see, I don't know what we can call this one, beta. Oh yeah. Well, it doesn't matter what we call it, really. So the angle, what was the angle here? CBA, right? So because these are vertical opposites, right, you can basically just say CBA is equal to, we have already proven, it's going to be the 63.43 minus the 8.17 over there, you see. So let's see here, 63.43 minus 8.17. So this is going to give us 55.26. Let's put here nicely 55.26, like that. Whew, this is all nice and all dandy. Like, oh wow. Oh wow. You see, IEB papers, they are also normal papers. So we should all just agree to that. Anyways, it says here, question 2, right? A parallelogram, A, B, C, D. Where is A, B, C, D? A, B, C, D. So this parallelogram, right, they said here it is such that the diagonal AC, where is AC? AC is 5 units. So this here is like equal to 5. And then AB is like equal to 8. Where's AB? There is AB. Here it is, orfate. AB, where are you? You are over here. Oh no. Snap. There we go. So let's actually write this nicely. This is 8. This is 5. Okay. Because it's a parallelogram, I'm like, we have to know that this is automatically going to be 8 as well. And then it says here, and it has angle this here, CAD, which is equal to 55. So let us make sure that we can see that this is equal to A, because why are you covering the A, man? Come on, you want to make our life difficult here. If this is 55, automatically you know that this is equal to 55, you see, because of alternating angles. So all these pieces of information, you want to make sure that you put that for yourself. So let's see, for whole 5 marks, wow, they want us to get ADC. Where is ADC? Whoo! Yo. Oh, okay. Oh yeah, cosine rule, sine rule, blah blah blah. That's the stuff we're going to use here. Because if you look at this triangle here, right, the good news is you have an angle and you have its opposite side. So that's one sign that you're going to use the sine rule. That's like one hint for you to use the sine rule. If you have a side and its opposite angle. So here, we already know that CD is equal to 8, CD is equal to 8. Even writing it is a bit weird. Because, I mean, like, you don't even have to put... This is not Euclidean geometry, so you don't have to put reasons and stuff. But, I mean, you know, just for the vibes, we can say here, opposite sides of a parallelogram. Parallelogram. You see, opposite sides of a parallelogram. That's weird. Hey, yeah. So with the sine rule, we can easily say, since we're looking for an angle, right, it's easier for us to put angles at the top. So we can easily say here sine D over the side here, which is 5 units. This is going to be equal to sine, where's the angle? 55 here. And the opposite side is like 8. So let's just multiply by 5 over here, times by 5, times by 5. Here we have like sine D. This is equal to... This whole thing here, you're just going to put that into your calculator, you see. Don't worry about putting this anywhere else, because I'm like, you're just going to be wasting your time, you know. Put this into the calculator. Oh no, let's actually do the whole thing once. Let's do shift sign here. Put this entire thing into the calculator, you see. Don't be afraid, you know. It's okay to put all these things into the calculator. Your calculator is strong, eh? It can take all this weight. It can literally take all of it all at once. So do not panic. Do not panic. So let's just see what this is. Let's just see. Let me see here. Into the calculator we go. And what we come out as, let us find the out. Let us find the out. It doesn't want to put into the calculator. Oh no. Hold on. Hold it on. Hold the door. I'm thinking of like what? Game of Thrones. Hodor. Hold the door. Well, I guess you may or may not have an idea of what I'm talking about, but if you're not a God fan, then oopsie. If you are, what's up? Yeah, I sound weird right now. But anyways, let's see. So if you're gonna throw everything into the calculator, you're gonna get your angle there to be 30.8 degrees. 30.8 degrees. Let's put here 30.8 30.8. So the idea is, if you look at your IEB papers, right, like right in the beginning, we know that in terms of like the number of decimal places that you have to like round off to, well, the one big idea is your calculator obviously has to be like in degrees and stuff, and they do want us to round off to 1 decimal place. So like, might as well change this here. Like, what was this a degree? Yes. So this was like 55, let's say 55.3 for this one, and then yeah, that's the final answer. So yeah, angles, you can just always make sure you put them in to 1 decimal place, or rather lengths and angles, because they did say that you should round off to like 1 decimal place unless stated otherwise. So here we've got a value for D. It says calculate the area of the parallelogram, technically speaking. So the whole area of the parallelogram, we can just use the area rule and then times by 2. So the good news is that here we have this angle, right, which is like 30.8. So what I recommend is, for us to use the area rule, we need to at least have an angle and the sides that are like on the 2 sides of the angle. Like, for what I mean is, for the area rule to work, we need this angle specifically, because we have 5 here and we have 8. So these the 5 and the 8, you see, they're on the 2 sides of this angle over here, which is good. You see, this is good. So the big idea with what we're doing here is that, let's get C. We can get it using, so let's say ACD, we can get that using like interior angles of a triangle. So here let's say AC, is it D? Yeah, ACD. Let's put this into the calculator. Hey, what you got? Let us say 180. Oh no, this is too thin, man. It's too thin. Come on, man. Come, have some McDonald's. Get a bit, Oopsie, that's just weird. Oops. 180 minus 55 minus 30.8. Let us see what this gives us in the calculator. Let us see here in the calculator, or in the calculator, as most people would want me to say, in the calculator. I mean, like, it just sounds so boring, man. Like, in the calculator is much better, So in the calculator, our angle for C there is like 94.2. Really though? Yep, 94.2. So we can just use the area rule here. You see, the area rule says half multiplied by one side, multiplied by another side, and then sine whatever the angle we have. So this here, we know that generically this is equal to the area. You see, I mean, like, we all know it, like, we all know it, man. Like, it's on your formula sheet. If you don't know it, well, guess what, now you know it. So yeah, congratulations, this paper is working now, you see. So the idea is, you just have to write down the 2 sides and then the angle in the middle there, you see. So the 2 sides here, we know it's 5 and 8. It really doesn't matter which one you make 5, it doesn't matter which one you make 8. The angle here, we worked it out to be 94.2, maybe, to you. Okay, so this is specifically the area of one of the sides. Let's say area ACD. You see, ACD. You see, that area, we're obviously going to need to multiply it by 2, because we have 2 triangles that look like that. So this is going to give us 19.95. So let's put here 19.95. This 19.95, we can just multiply it by 2 and then make sure we round off to like 1 decimal place. So here, area, hey, what's going on here? Yar. Oops, yeah, my handwriting, it's nice, kidding. What is this now? So here's going to be 19.95 times 2, which is going to be, so the area of A, B, C, D here, you see, is what we're dealing with. It's going to be 19.5 times 2. This is like 39.9. Ooh, very nice. We love to see it. We love to see this. So us, we're going to keep on moving forward, because we don't wait and celebrate yet. No, 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 no. It's okay to celebrate, but gotta keep on moving forward, man. Gotta keep on moving forward. So here it says, if 13 cos theta is equal to 5 and theta is between 180 and 360. This is an important question. And then they say, then without the use of a calculator, determine the values of the following. So this is a classic question. I mean, like, it's out of 2, but it's so classic because a scenario like this, you literally just have to draw a diagram for you to be able to work this out. So in this case, the 13, you're gonna have to divide it on both sides. You're gonna have 5 over 13, you see. Now from here, you're home free, because your diagram here, you're clearly gonna have to have a diagram in the Cartesian plane, because they told you that your angle is between 180 and 360. So you know that this is like 0, 90, 180, 270, and then here you're back to 360. So the big idea here is, this is a positive and a positive. So obviously your line cannot, if your line has to be between 180 and 360, it has to be somewhere here, you see, somewhere here or somewhere there. Now you can't put it there. The reason why you can't put your line in the 4th quadrant is because, you see, any line that you put has to always go to the x-axis. So this one would be wrong, because here you have a positive number, you see, but then here you have a negative. You see, that doesn't work, because here this is a plus. So the only scenario that works is the 3rd quadrant, you see. So in the 3rd quadrant, this is where we're gonna draw our famous line. You see, we're gonna draw this line here, and then we're gonna draw like a right angle triangle. In this right angle triangle, we're gonna put the ratio for cos. Cos is adjacent over hypotenuse. So this is like adjacent over hypotenuse, because the angle that we always use always has to be the angle with the x-axis, you see. So this is the angle adjacent over hypotenuse. Now this here, we can label it y, and you can get it using the Pythagoras theorem. So this squared, we know it's equal to y squared plus 5 squared, and then the y, you can just put it on its own. So here you're gonna have in your calculator 13 squared minus 5 squared, all this under square root. This is equal to like y, and then this should give us a 12. I mean, like, these numbers, they are so predictable now. Ha 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 ha, you see. But then remember, here it's a plus or a minus, you see, plus or minus 12. So because it's down here, this is where you have to be careful, and this is the mistake that I always make. Like, I always forget, put it down here, ne? You put a negative. So yeah, therefore sine theta here, it's quite simple. This is just opposite over hypotenuse, which is just negative 12 over 13. I'm like, look at you blazing through this like a boss, like a boss. For 3 marks, they want us to get cos theta plus 45. This kind of equation, yeah, it looks like you're just gonna have to use the what you call compound angles, you see. So this is gonna give you cos theta cos 45 with a minus sine theta, and then sine 45, you see, sine 45. So with this sine 45 and the cos 45, because they said we cannot use our calculators, on your answer sheet, you do want to draw this right angle triangle here for them to see that you know what you're doing. So here in this right angle triangle, you're just gonna, come on, man, come on, huh? Why you have to be an enemy of progress? We're flowing so nice, and then now we have to deal with these small nyana things. No, man, no, man, no. Cooperate. But anyways, this is going to be a 45 triangle, 45 angle there, 45 angle there. This is equal to this, and it's going to be 1 and 1. And then this becomes square root of 2. This is like a basic triangle. It's easy to remember. So don't think that it is anything hard or whatever. You see, because you're smart, you can remember it. Like, trust me. Trust. So cos theta, we have a value for that. Using our diagram, or just using using our diagram, or just this, you see, because our diagram says adjacent over hypotenuse. So this is like 5 over 13. With cos 45, likely it's just adjacent over hypotenuse. Very nice. Cos theta, sine theta is like opposite over hypotenuse. So that's like, be careful here, you see, negative 12 over 13. And then sine 45 is like what? Opposite over hypotenuse. That's like 1 over square root of 2, like that. Whew, that is the way. I like it. 5 times 1 is a 5. 13 times that's like 13 square root of 2. And then here we're gonna turn this to a plus, because a negative and a negative there gives you a plus. 12 times 1 is just a 12. What else? Ooh, goodness. Is bad. No, it's fine. 12 and then 13 here, it's gonna be like 13 square root of 2. You see, your denominators are all the same. So at the top, it's just gonna be 17. And then 13 square root of 2, like that. You see? Very nice. Very nice. Don't be scared. Don't be scared. If you had put all this into your calculator, it was gonna give you 26 at the bottom, and then it was going to give you what you may call 17 square root of 2 at the top. You see, so let me just add this as well, just in case you use other methods and all that stuff. You see, these are both exactly the same, because yeah, man, if you throw all this, I mean, they did say don't use a calculator, but I mean, the whole idea is if you have ways of showing what you used and whatever, because most people use like a table to generate a value for cos 45, and that table gives them like square root of 2 over 2 and stuff. So that's why I'm putting here as an alternative. Anyways, let's go to the next question. Question number, no, this is question 3. It looks like we're moving along just fine, to be honest. Like, we're moving along okay, you know, moving along okay. It says if cos theta is equal to this, no, if f of x is equal to cos 2x minus 1, and g of x is equal to this equation between 0 and 270, all this given. For 1 mark, they want us to write on the period of f. So here, it's just a matter of you knowing your theory, because your theory will tell you that the value in front of x there is the frequency. You see, frequency, you know, it is equal to, for a tan graph, it's 180 over period, but for a cos and a sine graph, frequency is just 360 over the period. It's a formula, you just need to know it. So this being said, let us see here, frequency. What is frequency? Frequency is a 2, you see, and then this is like 360 over p. Let's just put p for period. So you cross multiply here, you're gonna have 2p is equal to 360, and then p is equal to like 180. That's the way. I like it. Wait, no. Wait, what? Really? Yeah, man. That's what you're getting. The period is equal to 180. So this is saying for you to get a complete graph, it's going to take you 180 degrees. That's what period tells you. Here they said write down the asymptotes of g. So it's a basic 10 graph, and with the basic 10 graph, I mean, like between 0 and 360, you have this, right? Yo, what are you doing, bro? You have this between 0 and 360. In the middle, you have this, and then that, and then you have this, and then you have that, and then this is like 360. So the big idea here is you already know that this is where 270 is, you see. 270, this is where 90 is. In the middle, you have like 180 over there, you see. So this being 180, you know that your asymptote, if 270 is included, then it means the two asymptotes is just going to be x is equal to 90 or x is equal to 270, because 270 is like part of your given domain, and your other asymptote will be at 270. That's just 2 marks. Free 2 marks. Free 2 marks just from knowing the theory. The nice thing about this sketch question here that we're about to start with is that they have told us, like you see, they've given us a grid already. Like, wow, such nice people. Sketch the graphs of f and g on the same set of axes below, and then label all intercepts with the axis, asymptotes, turning points, and endpoints. We already do the 10 graph. The 10 graph, we already drew it. You see, there's an asymptote at 90, because it's a basic 10 graph, this one, you see. 10x. It looks like these guys had an easy paper as well, just like the 2020 caps guys. Like, legit, y'all had like such easy nice papers. Like, wow, man, wow, what a wow. I guess they were just lenient, you know, which is, I guess, okay. So here here we're gonna have our curve, right? It goes down like that. Yes, and then it goes down like that. You see, arrow, arrow. You have a thingy going up like that. There's nothing here. Don't put anything here. This, let's just label it g of x. And the course graph, now you have to know your theory. Your theory is telling you that in a space of 180 degrees, you're going to have a complete course graph. So in a space of 180 degrees, you have a complete course graph. The other thing is, this is telling you that, let me just show you what a basic course graph looks like, you see, so that we can just, you know, work with what we have down there. So here, if you have y is equal to cos x, right, then it means that your graph starts at +1, and it does this in a space of like 360. So the moment you have a period of 2 there, it means that in a space of like 180 degrees, you're gonna have a complete graph. So if you had something like y, let me draw it here. If you had something like y is equal to cos 2x, then it means that your graph is going to look like this. In a space of 180 degrees, that's when you have a complete graph like that. Meaning in a space of 360, you'd have like 2 of them. You see, you'd just have another one like that, and then this is where 360 would be. In our case in particular, this image here was moved 1 unit downwards. You see, this image here was moved 1 unit downwards. So instead of going between 1 and -1, our image is going to go between 0 and -2. So here between 0 and -2, that's what our image is going to do. And obviously, originally, you can see that a course graph goes like at like 90. This is like 270. In the middle is like 180. And this is 0. So what you want to do is to just divide all these key points. Divide 90 by 2, divide 180 by 2, divide 270 by 2. So you get those key points there. So instead of cutting at 90, it's going to cut it like 45, somewhere there, because it's going to like go down and then turn here at 90, turn here at 270, and then be a complete graph at like 180. And then obviously it's going to like repeat and go down there, and then by 270 it would like turn again. So this is like gonna go down like this, and then it's gonna turn at -2 rather. It's gonna go up. So obviously, if you need more assistance with like these kinds of graphs and everything, my recommendation is definitely the trigonometry course on the course platform, you see, of which the course platform, the link is right over here. You can also find that right in the description, you see. So you may be thinking, oh, this guy is just plugging himself. Well, trust me, this is a win-win situation. Like, there are a gang load of people that are getting distinctions from the courses. So if you want to be one of them, be my guest. If you don't, I can't force you, you know. I can't force you. So anyways, this is going to be worth 6 marks. But then you have to like label this. You see, they say this is f of x. You have to get the turning point. We labeled, we have the turning points there. So that's a check. Endpoints, we have those there. Asymptotes, yes, we have those there. Intercepts, it says a label or intercepts. Okay, label them. Okay, fine. 0 coordinate 0, and then this here, it's like 180 coordinate 0. This is a turning point, might as well label it. 90 coordinate -2. This is a turning point, 270 coordinate -2. And what else? What else do we got to do? Well, this is all closed up over there. This is there. Yeah, looks like everything is all good, to be honest. So let us just move on to D for only 2 marks here. It says use the graph to write down the general solution of x for this equation. So obviously, this is them asking where the graphs meet. So we can clearly see they meet here where x is a 0 and where x is like a 180. So the simplest way to put it is you can just say here x is equal to 0. Then you can say here plus k 180. And then you can say here x is equal to 180. And then plus k 180. I forgot to put the k as element of integers part. K is element of integers. K is element of integers. Fantastic. Very nice. For 3 marks here, right? They want you to determine the general solution of this expression. Whoa. This is like a totally different question. You see, it's just a normal general solution question. It's totally different from what we've worked at. And this is a basic general solution question. I'm like, come on. You see, this goes to the other side. And then normally when you're working with sine and theta, you just want to turn it into a tan, sorry, by dividing by cos on both sides. So if you divide by cos here, and you divide by cos all over there, you're gonna have 1 is equal to 10. There we go. Now solving for theta, I mean, like, let's write it the other way around because it's always easier that way, you know. Like, you know, you may be asking, why did I swap them? I just swapped them because it's easier to write the theta this side and stuff like that. So here our reference angle, we're gonna say shift 10 with the 1 here. And in your calculator, I have a feeling you're gonna get like a 45, but hey, you never know. You never know. So let's see what we're getting here. Shift 10 1, shift 10 1. We're getting a 45 over there. And this is like your reference angle over here. You see, this reference angle is like 45 degrees. So the big idea now is that you kind of need to, what are you gonna do now? Well, after you get on your reference angle, we said you have to choose a quadrant. So this is like CAST. So in terms of you choosing a quadrant, you have to be careful. Like here, let's see. You have to choose the positive ones where 10 is a positive. So it's this one and this one. So let's start with the first one. The first quadrant, you're just able to carry on with what you have. You see 45. That's your angle for theta. So here you can say theta is equal to 45 and then your plus K360 stuff. So here theta is equal to 45, and then I meant here plus K180 actually, because we're dealing with 10, plus K180. K is an element of integers. And then what? In the third quadrant, you can just say theta is equal to 180 plus your reference angle, and then plus K180. K is an element of integers, you see. So let's see here, theta is equal to what? 225, maybe 225. And then you can just say here plus K180. K is an element of integers. Nice. We love it. We love it. Well, that's a 4-mark question over there. It's a 4-mark question over there. It says prove the identities. So we need to prove this identity over here. It's a 4-mark question. Proving identities, it's quite easy. Like, don't stress yourself too much about proving identities. You should make sure that proving identities is stuff that you can do. So all these here, they're obviously going to change because you see the right hand side does not have any double angles. So the idea with double angles, I mean, yeah, rule of thumb is work with the side that looks harder. So in terms of changing this cos and this cos down here, you may not know what to change it to, but let this be a hint. You see, it looks like the bottom you can change it to like the difference of two squares. That other one that has sine squared and cos squared. The top one, since there's a cos here and there's let's just change bit by bit. You see, this here, it can only change to one thing, you see, so might as well change it to that one thing. There you go. This is a plus. So here, because there's a cos here, I mean, like, yeah, I'm getting the idea that we might as well do what? Well, to be honest, like, I really would not want to like overthink a question like this, because right now I am most definitely overthinking it. Because in terms of overthinking it, I'm basically thinking things like, okay, what do I change it to? Like, what if I change it to the wrong thing, and then the wrong thing eventually makes me like go in circles and stuff? So like, don't be afraid of doing that, because I'm like, at the end of the day, you know, just gotta do what you just got to do. And yes, I'm definitely stalling by like looking at this question and all that. But anyways, from what I can see here, it looks as though I can just change this to something that has a cos, as we said, because there's a cos here. So if we change this to the one that has 2 cos squared theta minus 1, we're gonna have a plus 1 over there. Now for the bottom, I had said we can change it to the difference of two squares, and I'm gonna stick with that because of this here. So here this is going to be cos squared theta minus sine squared theta, which is what we have on your formula sheet. So the top part, this cancels that. Likely here you can take out a 2 cos theta. You can take it out as a common factor because there's a 2 and a cos here, there's a 2 and a cos there. So let's do it. Should we read it? Yeah, I don't see why not. Here you're gonna have sine theta left on its own. Here you're just gonna have a cos theta left on its own, which is good, because it looks like at the bottom this can at least cancel something, because remember the difference of two squares is this here. It tells you you're gonna have a bracket, right? That is cos theta plus sine theta, and then wait, let me do this here, stroke, remove that. You're gonna have sine theta over here, and then here you're gonna have cos with minus sine theta over here, you see. So obviously you can just do the cancelling here. You see 1 here cancels 1 over there, you see, and then you're just going to have what you have on the other side. You see 2 cos theta and then cos theta minus sine theta, which is equal to the right hand side. Therefore left hand side equals right hand side. Fantastic, nothing crazy here. Marks only, they want us here to get as the following. Write down all the values of theta in the interval 0 to 180, okay, to which the identity is not valid. Okay, well, the identity that they're talking about is this one. You see, you can either use this one or that one. I mean, like, the easiest one is using this one, like, really, just use this one. So if you're looking at this identity, right, 2 cos theta with cos theta minus sine theta at the bottom, cos theta minus sine theta, this identity here, the big idea is that you want to think of things like asymptotes and, you know, all that shandies. Well, the idea here is, clearly we know that the bottom part, for this thing to be invalid, this is just a 2-mark question, so don't overthink it. For this thing to be invalid, the bottom part has to be a 0. You see, that's the first thing we can start with. For this to be invalid, the bottom part has to be a 0, because a fraction cannot have a 0 down there. So let's work out where this is a 0. If you can recall from up here, we worked out where this is a 0. This is a 0 where your x is equal to 45 or 225. So let's see here. So here we know that dot dot dot, it's already worked out, so don't worry about it. You can actually do that in your exam as well, because there's a point in time where this was worked out. So here you can just say theta is equal to 45, because I mean, if this is 45 and this is 45, this is exactly the same number. So this minus that will just give you a 0. The other thing we have to remember is that here we said theta is equal to 225 plus k 180, and then k is an element of integers. Well, the sad thing is, whatever we do here, for us to find our second value, we may want to use this expression. Let's see here, which expression would we want to use in the interval. What's the interval here is 0 to 180. For us to find another value that is going to cause this thing to be like invalid and stuff like that, we really do have to like somewhat think outside the box. In terms of us thinking outside the box, you can think to yourself, what do we have? Well, we've seen that the bottom should not be a 0. Now the only sad thing is, depending on what k values we throw in there, it's really not going to help us much in terms of like getting the other solution to this equation. So yeah, at this point in time, we kind of do have to think deep. And thinking deep, why do you have to think so deep, bro? Like why you gotta think deep at all? Like, it's not that deep, it's not that bad. So what we can think of is, let's see here, let's see, the one other thing is, we do know that a value that will cause this and this to be equal to each other is something like 135. And you may be asking yourself, why did I think of 135? The idea is when you're going to be working with values like these, right, or expressions like these, you just want to work out where this minus this will be a 0, meaning you want to work out where this and this will be the exact same value. So I mean, if you think of your theory will tell you one thing about a sine and a cos graph. If you draw these two graphs, right, on the same set of axes, this is 1, this is -1. Let's draw a sine graph here, a cos graph here, from 0 to like 360. That's a cos graph, right? A sine graph would look like this. It would go up and then turn somewhere there. No, it would go up and then cut the x-axis somewhere there, like that, you see? And then it would go down and then like that, you see? So what you want to recognize is that at 45, obviously somewhere at 45, like somewhere here, this is like 45, right? The funny thing is this is not to scale, but these graphs should be like intersecting each other and all that. That's just kind of sad because my graph is not to scale. Let's pretend this is like 45. You see the graphs are intersecting each other. Now if you know your theory, the other point where the graphs intersect, it's at 135. You see this in the middle here is obviously 180. So let me put here 180. There's like 180 of, oh, I lied, I'm lying, snap, this is like 180. I wanted to get, no, I don't want to get the point where they intersect. I want to get a point where they have the same y value. So let me just erase this. So these graphs, actually, as I'm like explaining all this, right, I'm like realizing that this is like actually the complicated way of doing it. So I mean, like, why not, let's just pivot and think of an easier way of stating why it is that the other solution here is 135. We can just use our quadrants. You see, in terms of like our quadrants here, you can just think to yourself, okay, fine, our reference angle was like 45, right? So already you know that. Let me do this here, just take this here, copy it, and let's paste it down there, and let's forget anything about positive, negative, what, and then just work with all the quadrants. So in the second quadrant here, we know that would have had 180 degrees minus our reference angle, and then this would be equal to our value of theta. And then here 180 minus 45, this is going to give us 135. You see, this is where the 135 is like coming from. It's just a matter of realizing that here, if you're going to work out where this is a 0, you see, you need to consider all possible options regardless of any given quadrants or anything, because remember here you're getting the general solution. So because this is like the general solution, it is basically linked to just these two quadrants specifically. But then in a scenario where you have like no restrictions or anything like that, then if you're going to work out a solution for this, just use like all the quadrants and then get all the relevant answers to your specific questions. You see, it's more like improvising in the heat of the moment. Whew. Anyways, question number 5 says the following. Question number 5 is a proof. It's one of my favorite proofs because it's the easiest one. Like, oh my gosh, it says here, prove the theorem that states the opposite angles of a cyclic quadrilateral are supplementary. So you have to prove that this angle here plus this angle here, you have to prove that they are equal to 180. So the easiest thing is to construct, in terms of the construction here, the construction is so basic. It's just you constructing CD, AD and AF. You see, construct AF and AD. That's your construction, and that's with the mark. So we're trying to prove that angle C plus E is equal to 180. So we're trying to prove that C plus E is equal to 180. So the way I always look at this proof is, or with most proofs, always remember that you're going to use specific theorems to help you. So the one theorem that we're going to use here is the theorem that talks about angles at the center of a circle. So that's the first theorem we're going to use to prove this question over here. Actually, let me draw a nice circle. Come on, circle. You know you want it to be drawn. Don't be difficult. So we're going to use this theorem here, the one that states that an angle at the center of a circle is just double the angle at the circumference. Ooh, snap, man, snap, snap, snap. Let's do this. We're actually going to use this theorem twice. We're going to use it in this format, and then we also just need to consider that this theorem also works if you are dealing with like what, like an obtuse angle, you see, because with this theorem here, if I make this a bit bigger, this circle, what you will note is you can also have an angle at the center that looks like this angle here, né? If you draw this and you draw this, for this example here, you know that you're going to be working with the acute angle here. This one here is the one that is double that one. But then when you're looking at the pink one, you're going to have your angle as this one here. This one here is the one that is going to be double the angle at the circumference. The angle at the circumference is going to be this one over there. This is the theorem we're going to use. It's one theorem, but you have to look at it in two different ways. Now, the big idea is, let's label this A1 because of our construction, and let's label this A2. So to make your life easy, just remember that A1 plus A2 gives you 360 degrees because it's angles on a straight line. So let's do that. A1 plus A2, 360. The reason is angles around a point. Did I say angles on a straight line? Oh my gosh, I meant angles on a straight line. I'm sorry. I meant angles around a point. Yes, man. Angles around a point. Angles around a point. Yes. Anyways, angles around a point. Let's see here. So now we just need expressions for A1 and A2. So that's going to be quite easy. A2, we know it's double C. A1, we know it's double E. That's the easiest thing to do it. You see, A1, you're going to say it is 2 times whatever E is. The reason is angle at center of circle. You see, center. Ooh, come on, man. Come on, man. You can write a better center than that. Center of circle. Circle. And then here you can say A2 is equal to double angle what? Angle C. And then what are you going to say? Angle at center of circle as well. At center of circle. You see, this is the easiest proof, because here now you can just throw this and this over there. Then you can say, therefore, 2 of E plus 2 of C is equal to 360. And then you can take out 2 as a common factor. This is like E plus C is equal to 360. And then you're going to need to divide by 2 on both sides. 2 on both sides. So dividing by 2 on both sides, you're going to have, therefore, E plus C is equal to 360 divided by 2. And then there you have it. E plus C is equal to 180. Easiest proof on the block. I promise you. This is one of the easiest proof out there. Like, when I saw it, I was like so happy. I was like, yes, easy proof, yes. B says, in the diagram below, the two circles intersect at C and E. And then they said here, G is a point on chord HF. Where is HF? HF, you have G there on the chord. They didn't say G is in the middle. They just said G is a point on the chord, you see, of the bigger circle. And then it says here, GE is a tangent to the smaller circle at E. So GE is a tangent to the smaller circle at E. Let's see here. GE is a tangent to the smaller circle at E. There you are, go. So what else now? What else? What the else? My opinion, my advice, my opinion. What? That is weird. What I can safely say is, if you see something as a tangent, already do what you can to write out stuff that are related to the 10-chord theorem. So with the 10-chord theorem, it's all a matter of spotting the tangent and the chord. The angle there is going to be always equal to the angle opposite the chord that you're dealing with. So if this is like 73, this is already 73. So just put it there, you see, so that you don't forget. And then they said here, HFC is 75. Wow, where is HFC? So HFC is 75. The lucky thing is here HCEF is a cyclic quadrilateral. So you already know that opposite sides add up to 180. So if this is 75 and this is like 73, you can easily get this part here by using opposite angles of a cyclic quad, because you know that the pink, the green, and the 75, they all add up to 180. So in the future, we'll definitely use that. D is, we might use it, we may not, who knows. Here it says D is a point on the smaller circle. Where's D? You see, as I'm reading the description, I'm basically checking to see where this information is. D is a point on the smaller circle, and they say this is equal to 73. Very nice. This question looks like it's going to be easy. For 5 questions, for 5 marks, it says give reasons were required, determine the size of E1. Very easy. So we have to tell them we know what E2 is first. So E2, we're going to have to say that this is equal to 73. The reason is 10 chord theorem. You see, that's like 2 marks easy. 10 chord theorem. And then you have angles on opposite angles of a cyclic quad, right? So here you have H plus E1 plus E2. You know that this is equal to like 180 degrees. The reason you know that this is equal to 180 degrees is because it's angles, opposite angles of a cyclic quadrilateral. You see? Opposite angles of a cyclic quad. There we go. So you can just throw angles in this formula here. You see, H we have, it's 75. E1 we don't have, that's what we're looking for. E2 we have, it's like what did we get for E2? E2 is 73. This is got to 180. Put everything on one side, you're gonna have 180 minus 73 minus 75. Oof, this is interesting. So you're gonna have it looks like you're gonna have 32. Are you gonna have 32? I don't know. It looks like it. 32 is what you're going to have over there. Well, I have actually not, like my mental math, please don't fail me, but I'm hoping you're 32, okay? But it is 32. That is it, you see. So analyzing your sketch beforehand really does help. So anyways, here, let's move on. C says the following. In the diagram below, what does it say in this diagram below? It says here, C is a point on chord BE. Where's BE? Okay. See, you see what I did there? Always read the description and always look at the, what you call, the sketch. You see, never do one without doing the other. You will be robbing yourself of like marks. So this is a chord. Then there's point, wait, they said here, C is a point on BE, yes, and F is a point on chord DE. So there's just this point here and just this point there. So I'm already seeing some proportionality stuff. Even though these may not be parallel, I'm already seeing them making us prove that angles are similar, and triangles are similar and stuff like that, because this is just how these questions are. When you've gone through a lot of past papers, trust me, you'll be able to spot these trends and stuff. It says here A is the center of the circle. No, A, right? They said A. Where's A? A here. A, the center of the circle, lies on FC. So where's FC? There's FC over there. There's A in the center. So automatically don't forget that if this is 86, this is 43. Put that for yourself. Don't think you're going to put it later. And then automatically also, you see, your theorems need to remind you that, just as we're seeing here, you see here, they didn't say anything in the description about these two being equal. Or did they? Yeah, they did. They said EF is equal to FD. So automatically we should know that this is equal to 90 because of our theorems. This is like literally theorem number 1. You see, a line from center bisects chord. So here they said here, this is 86. This question is going to be quite easy. For 1 mark, they say determine D2. D2 is going to be quite simple because we are dealing with an isosceles triangle over there. You see, this is a radius, this is a radius. So here we can say that D2 is equal to well, it's a 1 mark question, so I would rather just do everything at once, but it doesn't matter. Let's just do it bit by bit. D2, these are equal. We can say opposite angles of an isosceles triangle. Isosceles triangle, and then we can say here AD is parallel. No, is equal, man. Come on, man. Is equal to like this, and then we can just say the red eye. It's like so many reasons for the same thing. I mean, just so that you can feel comfortable, you know. So here we can just perform a calculation now. 180 is going to be equal to 86. No, 180 minus 86. You see. Let me just do this. D2 is what we're looking for now. D2 is 180 degrees. We're gonna minus the 86, and then whatever is left, we're gonna divide it by 2. You see, that's how we're gonna get D2. Of which, putting all that into our calculator, we're getting 47. 47 is the magic number. Thank you so much. Let's see here. Moving on, right? They're telling us here that is it really 47 though? I guess it is. I guess it is. Is it really? Yes, maybe do. Yes, it is. So let's see here. You have got what is this now? This is 1 mark question. Determine the size of DEB. Where is DEB? DEB. Ha, that's 43, bro. Come on now. 43. So what is 43? It's DEB. DEB, because of angle at the center of a circle. Angle at center of circle. At center of circle. There you go. And then for 4 marks here, they said we should what should we do? We should prove that DACB is a cyclic quad. DACB is a cyclic quad. That's for 4 marks. Where's DACB? D. Let's actually use the purple there. DACB. They want you to prove it's a cyclic quad. So proving a cyclic quad, we have 3 ways to prove a cyclic quad. You know, the tutorial on proving a cyclic quad is there on the main channel. We are going to see which way we can use here, because proving a cyclic quad, I mean, you're either going to prove that opposite angles add up to 180. You're also either going to look for angles in the same segment, or you're just going to look for an exterior angle that is equal to the opposite interior angle, of which here I'm already seeing this stretched out, you see. So I can already start thinking of like exterior angles of a cyclic quad and stuff. So meaning if we can prove that this angle here is equal to that, then we're good, you see. So the D2 here, we said it was 47. And if we can prove that this is equal to 47, then we're good, you know. So this one's going to be quite interesting, but we don't have to panic. You don't have to panic. It doesn't seem like it's going to be a difficult one. So the one thing that I'm spotting here is, okay, remember this is a 90-degree angle, right? And let me see if I've gotten the right cyclic quad here. They said DACB. Where's DACB? DACB. Okay, fine. Looks like we got the right one. So I'm looking for, let's see if I can prove that this is equal to like, well, there's this angle there, but then there's also another one here. Let me actually not like forget it. This one here, you see, that's also an angle we could use like one way or the other. So yeah, I'm like legit low-key stalling over here. I'm like, you know, legit low-key stalling over here, because I mean, just trying to, you know, trying to do what I gotta do. Oh no, this is quite simple. Angles on a straight line add up to 180 degrees. So remember this here, we know this is 90 as well, so we can easily use that to get angle C1 there, because we want to prove that C1 is equal to 47, because if these are equal, then we have an exterior angle that is equal to an opposite interior angle. That's one law of cyclic quads. So let's just prove that EFC is 90 degrees. Let's just tell them that EFC, EFC, this is equal to 90 degrees. The reason there is gonna be angle from center of circle, or line from center of circle. Line from center, Brody, center of circle, bisects chord, there we go. We can just even end it at angle at center of circle. That would be fine. So here now you can say therefore C1 is equal to 47. So you can say therefore C1 is equal to 180. Whoo, my hand is equal to 180 minus 90 minus 43, and then this is just angles inside a triangle. C1 here is going to be equal to like 47 degrees. There you go. So here you can then say therefore DACB is a cyclic quad because an exterior angle is equal to an opposite. An exterior angle is equal to an opposite interior angle. That's the way. I like it. Don't mind me handwriting. Or rather my foot writing. Because you do not know, right? Am I really writing with my hand, or am I really writing with my foot? I guess we'll never know. You can hit me up. I'll let you know. You can hit me up on IG. See my IG handle over here. Be like, hey, yo, bro. So, is it a foot or is it a hand? If you literally just DM me saying that, like the first person that DMs me saying that, right? Is it a foot or a hand? If you can DM me saying that, the first person to do it, just like DM me saying something like, is it a foot or a hand? If you literally do that, the first person to DM me saying that, I'm going to give you access to the course platform at no cost. See, access to the all access pass, just legit for saying that. The first person to do it. So it could be you, Don't think to yourself, oh, it's too late. Someone probably did it. Trust me. Most people don't do these kinds of things. They just go, oh, I'm too late, or oh, he's joking. No. Just DM me saying, is it a foot or is it a leg? No, is it a foot or is it a hand? And then I'll give you access to the course platform, because I will know exactly what you're talking about. I know you'll be talking about my handwriting and stuff like that. But anyways, let's move on to question number 5. We are like low-key halfway through this paper. And yeah, the universe is generous today, Oh, question 6. Oh, wow, man. We just did question 5. Oh, wow, this is so amazing. Things are flowing so nice, this paper. These 2020 final papers, even the CAPS one. These papers, these were easy. Let's not lie. But anyways, for 1 mark here, they said, refer to the table below and answer the questions that follow. This looks like we are dealing with statistics, you see? So in this statistics question, they have given us this data. So in this data, if you're going to get the correlation coefficient, you have to put this data into your calculator first, you see. So putting this data into your calculator, hey, come on, bro. I'm trying to just draw like a line that is almost straight. So in your calculator, you're going to press mode. This is the steps you follow, you see. You're going to press mode, and then you're going to press on like stat. And then you're going to press on like a plus bx for least squares regression line. And then you're going to throw in data. You see, there's going to be a column for x. There's going to be a column for like f of x. And that being said, you know that you are going to have, what else are you going to have? You can throw in the data. After you've thrown in the data, you're just going to press the AC button. After pressing the AC button, you're going to press shift. And then after pressing shift, you're going to press the number 1 button. After pressing the number 1 button, you're going to go to, I think, should be reg. And And then from reg, you can choose R. Your value of R here is just going to be a 1, which is quite rare, like super rare. But I mean, like, that's the correlation coefficient. Now, if the correlation coefficient is a 1, that's like a straight line, like a perfect straight line. So here it says, what can you infer from your answer from above? You see, this is like positive, perfect correlation. There you go. Nothing too crazy there. The equation of the least squares regression line. Here they said use your calculator. Yes, as we should, right? We should use our calculator to determine the equation of the least. Determine the line of best fit in this form. So the line of best fit in this case is the least squares regression line. You see, least squares regression line. Just in case you're wondering, what do they mean by line of best fit? It's the least squares regression line. So getting the least squares regression line, it's quite simple. You just need your A and your B value from your calculator. You do these exact same steps, but then instead of choosing R, you're going to choose like 1. You're going to choose A. A in your calculator is going to give you the number. What is it going to give you? Let's check in the calculator. In the calculator, it is giving you a 13. For B, it is giving you a 3. So here, this is going to be equal to 13 plus 3x. You see, this is just going to be calculator work. So all this, you need to be able to know how to do this by now. If you don't know how to do this, you can always check out the tutorials on the course platform or on the YouTube channel, like my main YouTube channel, because the main YouTube channel has, like, you know, like the tutorials and stuff. What am I saying? Yeah, on YouTube, just search Bright Chunk Brains. You'll find the main channel, you know, and you'll find like the stats playlist. It's quite dope. Anyways, for here it says give a positive value of x where it might not be a wise decision to predict a value of y using the line of best fit. Explain your answer. Wow, this is like a weird, strange question. But they said give a positive value of x. So looking at our data, right, we have to think of a positive value of x. What was even the description here? They didn't give us much in this description. But hey, let's just wing it and see what we can do. You see, let's just wing it and see what we can do. So let's see. Give a positive value of x where it might not be a wise decision to predict a value of y using the line of best fit. So for something where your line of best fit won't work, you can use a value that is either a bit too high from this data or too low from this data. So in our case here, I mean, like, you could easily choose something like, you know, a 3 or a 4, because that's, like, you know, quite small. And then you can choose something like something maybe high, like 145 or something, you see. So just choose either a big number or a small number that's a positive. So here, let's say here a positive value, I would choose like 148, you see, because let's say here, because it's a bit too high compared to the other numbers, compared to the other numbers, Fantastic. Whew. Okay, moving on. Ain't no time to waste here for 1 mark. It says we have given you're given a frequency polygon here, a cumulative frequency curve, as they say. So here it says below is a cumulative frequency curve that represents the amount of time people spend looking at a screen each day. Ooh, yeah, hey, we spend time, eh? We spend time. Hey, I'm not even going to lie. Now I'm one of them. I spend the whole day with my eyes on a screen. Not because I'm be watching Netflix. No. Ooh, It's just that, you know, when you're on your phone on the laptop, on the tablet. They're all screens, but it is what it is. So here it says, it represents amount of time people spend on their screen. So here it says number of minutes on the screen during a day, and then the number of people. Whew, wow. So it looks like 140 people were surveyed, and it looks like the most minutes that a person spends on a screen in a day is 150 minutes. That's so small. Oh wow, this is a lie. Now I know I spend way more. I mean, just like making this is like me spending way more in front of a screen, you see. And you watching this as well. Ha 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 ha. How many people spend between 30 and 60 minutes on a screen during a day? So between 30 and 60, you see, it's between 30 and 60. So people that spend 30, it's people that spend less than 30, it's 20 of them. And then people that spend, so what you want to do is you want to trace the 60 and the 30 to the tally here on the left, because this is saying people that spend less than 30, it's just these 20 people. So 60 people in total, you're going to minus these 20 people that use less than 30, and then you're going to get the ones that are between 30 and 40. So between 30 and 40, between 30 and 60 here, it's going to be 60 minus 20, because these 20 use less than 30. So here 60 minus 20 is going to give you a 40. Come on, bro, you can't even write numbers nicely. I mean, I can understand paragraphs and letters and words, but even numbers, man, not numbers, man. No, man, no. Write numbers at least a bit better, numbers. that sounds so nice. Numbers, because numbers is just so boring. But anyways, that's just 40 people. We can write people over there just for the vibes, like you know the vibe. Where in the world is Oabile, guys? That guy, he just deserted us. But at least he's in metric this year, as of this recording, obviously. So maybe he'll be back. So for 2 marks here, it says what percentage of people spends more than 120 minutes on a screen during a day. So percentage of people that spend more than 120. So obviously 120 starts here. So people that spend more than 120 minutes is just going to be these ones here. So if you trace this to your line, it's gonna be like from here until there, you see, because it's like there and then there, you see. It looks like just 10 people. So but they're asking for what percentage spend more than 120. So it's just 10 people, but it's 10 people out of a total of 140, you see, because it's 140 in total, but then only 10 of them spend more than 120 minutes. So here you're just gonna multiply this number by 100, and then what you're gonna get, I don't know. I really don't know. I really don't know. I'm just gonna check in the calculator. So 10 out of 140, this is like 7.1% if you round it to one decimal place, as we should, according to the instructions in the beginning. So we are halfway through. Wow, man. Wow, like, oh wow, this is so amazing. Yo, let's keep moving on, Let's keep moving on. Question number 7. So my assumption is that the next few questions are going to be like hot and heavy, like big marks tamper questions, because these IEB questions, they like to do that. They like to just have 8-mark questions, just flying around there. But anyways, let's see. It says B, question 7. This says the box and whisker plot represents a summary of the results of students who wrote the same maths test. It says here in class A there are 28 learners. In class B there are 25 learners. You see now. You see now when you're dealing with two sets of people, two sets of data, and it's not the same amount. You see now. It says here, B, there are 25 learners, including the student represented by the point P. Where is the student represented by the point P? Sham. This is weird. But anyways, it says here, for 3 marks, a data value is an outlier if it is less than this, yes, or greater than this, yes. This is something that I definitely mentioned in one of like the the statistics tutorials, because in the statistics playlist, right, obviously things like the statistics playlist, you basically go through what do you go through? You basically go through all the basics that you need to know about, like, statistics and stuff like that. Oh, there's actually a tutorial on outliers. Yeah, I think there is a tutorial on outliers, if I'm not mistaken. I'm like tempted to go to the channel right now and like show you, but let's answer this question first and then I'll show it to you, just to show that the stuff on the channel is stuff that is relevant and stuff that helps you in like exams and stuff. So with all that we're supposed to do here, they said a data value is an outlier if it is less than this value here, or if it is greater than this value here. So Q1 has a formula. This is the interquartile range. It also has a formula. So we have to get Q1 and the interquartile range, obviously. So luckily, because of our box and whisker diagrams, let's see here. What are we talking about? We have to be careful. Let's see here. A data is an outlier if it is this and or that. Show that P is an outlier. So if we're talking about P, it means we're talking about class B. So if we're talking about class B, our box and whisker diagram tells us that this is Q1, this is Q2, and this is Q3. I just wrote it down here so that it's not cluttered up there. It tells us low-key that this is the minimum. But then the funny thing is, this is the minimum low-key, but this is just an outlier. So I think they just literally excluded it from the box and whisker diagram because it's like way too far from the rest of the data. This represents the maximum. And then let's prove that P is an outlier. So for us to prove that P is an outlier, we technically see P is like towards the smaller numbers. So we can just prove that P is below this here. So Q1, we know it was 60. So 60 there, minus 1.5. And then our interquartile range is just Q3 minus Q1. You see, interquartile range is just Q3 minus Q1. You see, so Q3 is like a 80 over there. Q1 is like a 60. So this is going to give you like a 20. So all this into your calculator, you are going to get the 30, because this is like 20 times that. This here is going to give you a 30 at the end of the day. So here you can see 30 is like somewhere there. You see P is below 30. P is below 30. That's all you need to know. Therefore, it is an outlier, you see. Therefore, it is an outlier. Anyways, let me just show you something on the channel, like the main channel, in terms of like the statistics playlist. Because in the statistics playlist, right, there is most definitely what you may call, let's see here, where do I need to go? I need to go to the channel, your channel, danko. I need to go to playlists, and I need to go to like the statistics playlist, so that I can show you the tutorials that are there, and so that I can show you that the outlier one is there. So if you look at the tutorials here, there's one here that says statistics, calculate outliers correctly, because they see there's like a basic one here which goes through like the revision, then it goes the one on distribution. Now one on outliers, even if I pause on the thumbnail, I'm pretty sure you saw there was like one person disliking. Who's this person? Is everything okay at home? Hey, I hope so. But anyways, let me just skip this thing here and skip to a point where I was talking about outliers. So here you see I said that outliers are less than this value over here. You see, that's option 1, or they are larger than this over here. You see, that's where I spoke about outliers. So you see, these kinds of questions, you need to be careful, you see. And you also just need to what am I saying? I feel like I'm just blabbing now, Well, I was just trying to showcase that the channel is useful, and you will learn some of these things from the channel if you like go through the tutorials, blah blah blah, the course platform as well, yada 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 yada. Anyways, moving on. For 2 marks here, it says the teacher of class B says that their data is skewed. Okay, state whether the data is skewed to the left or to the right. Explain your answer for 2 marks. So we're going to give an answer as to where it's skewed to, and then we're going to state why we have said that. So here, if you look at our I just want to show you something here so that you can also refer to these tutorials when you're going to be like studying and stuff. So in terms of skewness of data, it all depends on the mean and the median. So if you look at these three here, let me try and increase the quality here so that we can see nicely. Advanced, let's go to 1080p please. So if you're looking at these three here, you see there's like skewed to the left, normal distribution, and like there is skewed to the right. So if you see here, these three, right, in terms of whether something is going to be like skewed to the left or to the right or whatever, these all have like 3 specific formulas. So I'm just waiting for me to like, there we go. You see, if your data is going to be skewed, if it's going to be normal distribution, then the mean is equal to the mode and it is equal to like the median. If it's going to be skewed to the right, then the mean minus the median should be bigger than 0. Here, if it's going to be skewed to the left, the mean minus the median should be smaller than 0. So the only strange thing here is that with our data, right, just looking at, if we don't have the mean, obviously we can just look at the way the tail of the shape is behaving. Like you see here, it's more longer on the right here, and then here you can see it's slightly more longer on the left there. So if you look at class B, right, class B, you can see it's more longer on the left here, so it's definitely skewed to the left, you see. So here, because it's skewed to the left, you can basically assume that the bulk of your data is to the left here, you see, because this is saying the median is over there, you see. So I mean, half of your data is technically to the right, and then I mean, like, you may be thinking to yourself, yeah, I mean, this is the value specifically in the middle, you see, because that's like the median. But then here it says, here we're going to say that our data is like skewed to the left, because here the mean is technically to the mean, which is the average, is technically to the left of the median, because remember, the median basically gives you an idea of like where the middle of your data is, but then your mean is either going to be on the right side of the median or the left side of the median. So because our mean is on the left, we can see our mean is on the left, because this is the part where it shows that we have like the tail of your box and whisker diagram. Let's just think of it that way. Just look for where the tail is, you see, the longish part. This is on the left. So here we can say skewed left. Let's say here skewed left. And if it's skewed to the left or to the right, it just gives you an indication of where the mean is. So here it's skewed left, and then we can say here because come on, bro, you can't spell because. Hey, you know, the one way I remember because is by saying beka use. Like literally until today, I don't even know when I started, but it was a long time ago. When I want to spell because, I say beka use. So it's skewed left, beka use. The mean is to the left of the median. The median, that's what the tail tells us. Ha, get it? Tail tells us. 3 marks here. It says one of the teachers states that 13 students in the grade got between 45% and 60% for the test. Could they be correct? Wow. Okay, for 3 marks, you can already see that's quite an intricate question there. You see, it's not pop and place at all, you know. This question here is not pop and place. I repeat, this question is not pop and place, because whatever you're going to write here, you need to back it up. You need to back it up for 3 marks. So let's read again. It says one of the teachers states that 13 students in the grade. So it's, remember, 13 students in the grade. This is both for class A and B, because it's 2 classes, but they're both in the same grade. So 13 people amongst these are 40, these are technically 53 people. Amongst these 53 people, 13 of them, she says here, she states that 13 students in the grade got between 45 and 60 for the test. Could they be correct? Could this teacher be correct? So if you think of it, let's just compare data from each of them, you see. So in our case, let's see, between 45 and 60 for class A. Let's see where 45 is. 45 is over here. 60 is like over there. So I mean, like, let's think of it. Q3 rather. Q3 is here, ne? And then the maximum is there. So remember, Q3 represents the spot where 75% of your data is. Like 75% of the data is towards the left. So this here is just 25% of everyone. So class A, we know that there are how many people? There are 28. So here, let's see, 25% of everyone. Let's just check this out. So between 45 and 60 for class A, right? So let's say here class A, we know that 23%, 25% rather, 25% of 28. Let's see what this is in the calculator. This is going to give you a 7 because it's just 25% times 8. The percentage symbol, you can put it like this. Those are the people between 45 and 60. For class B, we know that if you look at it nicely, right? For class B, this is Q3, right? Meaning before look at where 45 is. This is 45 and 60, right? So between 45 and 60, this is also low key representing 25% of the people. So 25% of 25 is people here that got between 45 and 60. So let's see here, 25% of 25. This is what? In your calculator, this is just going to come out. If you round it off, it's just going to give you a 6, you see. So let's see here. This being given 7 and 6 people. Let's see if that adds up to like 13 at least. So 7 plus this is definitely giving a 13. So 7 plus 6, this is got a 13. So you see, you have a calculation to back up your yes, you see. So you can say here, therefore, yes, because there's your reasons, you see. There's the 7, there's the 6. You've proven that there are 13 people that are between 45 and 60. Very, very nice question, this one. B says, the table below shows the height of trees in a forest. The height of trees in a forest. So this being the height of trees in a forest, let's see here, between 0 and 2, right? The height of, what does it say here? The table below shows the height of trees in a forest. So okay, so this is saying trees with a height between 0 and 2 meters, right? You don't know how many trees those are. But then remember, this is frequency, not cumulative frequency. The reason I'm stating what I'm stating is because if you think of the next column here, the next column could easily be like cumulative frequency. You see, cumulative frequency. This would be a column where you would be like adding the values one after the other. You see, you would have a P, and then you plus the 165, and then you plus the 290, and then you plus that 185, going on and on. That would be like a third column here, cumulative frequency, you see. So let's see what 3 marks are going to get us. They say it here, if, or what we need to do for those 3 marks. It says here, if the appropriate mean for the height of trees, the approximate mean for the height of trees is 5 meters. Calculate the value of P. So if the mean is 5 and you have data like this is what you need to do. This is what you need to know how to work out the mean, right, for data like this actually. So when you work out the mean for data like this, what you need is firstly the midpoints of all these numbers. So the midpoints of all these numbers, it's quite easy. You literally just be saying this plus this and then divided by 2, going on and on and on. But luckily, I mean, like between all these numbers, we can already see what's going to be in the middle. Like here, what's in the middle is like 1. What's in the middle is like 3, because between 4 and 6, the middle is 5. Between 6 and 8, the middle is 7. Between 8 and 10, the middle is 9. So the mean here, you're going to say 1 you're going to say 1 times this plus this times this plus this times this plus this times this plus this times this, and then you're going to divide it by all this here. That's how you get the mean for this kind of data, because you're basically saying that you're going to have a tree on average that is like 1 meter long. You have p of those, you see, and then because you're adding heights here, you see, the next set of heights you're going to add is trees that have an average height of like 3. You have 165 of them. And then you're going to add trees that have an approximate height of 5. You have 290 of them. And then you're going to have trees that have an approximate height of 7. You have 185 of them. Trees that have an approximate height of 9, you have 75 of them, you see. So the big idea with all this is that your mean, you would get it by taking all this here and then dividing it by all the trees that you have. So all the trees that you have to be careful now, because all the trees that you have, it's literally this plus this plus this plus this plus p. In your calculator, that's going to give you 715 plus zp. Nice, very nice. So we have to be careful here. So what now? At the top, obviously all these calculations at the top, you're going to, don't overthink it, don't overthink it. All this here, they said that the average is equal to 5. So if the average there is equal to 5, then yeah, we just have to be careful. Like, we legit just have to be careful. Like all this, right? I know what I'm about to do right now, you're not going to be very happy with it, but like, let me not do that. Let me show all the steps, because I'm like, why not, right? Let's not be lazy. So the first bracket, 1 times p. This is just gonna give you a p. You see, this number here plus this number here plus this number there plus this number there. Let's see what that is going to give us. I'm just going to put it in the calculator. So this is giving us 3,915. You see, this is over 715 plus p, and then this is equal to like 5. Let's put it over 1 so that we can easily like cross multiply and stuff. So 1 times the top part here is going to give us 1 and 3915. This times the 5, it's just going to be, what is 175 times 5? 175 times 5 is just 3575, and then 5 times the p there is going to be 5p. Because we're trying to work out p, we can take the ones with p to the other side, the ones without to the left. This is going to give you, what is it going to give us into the calculator? In the calculator, it's like positive 340 on the left. This is good to like 4p. And then if you divide by 4 on both sides, your answer there is going to be 85. You see, this is quite important. Knowing how to work out the average here, you see. Knowing how to work out the average here is like super duper important. Okay, let's keep it moving. For 2 marks here, they said 200 new trees with a height of 10 centimeters were planted. Once these have been recorded, it is given that this thing here is equal to 6,520. Then they said determine the new approximate standard deviation. So the good news is this is giving you the standard deviation, because the standard deviation gives you an idea of how it gives you an idea of like how much on average each piece of data is away from the mean. So that's why here you'll see that they're taking every piece of data and they are checking how far is it from the mean, right? And then they're basically adding up all those numbers, and then eventually they're just going to divide it by how many numbers you have. So here, with a formula like this one, right? Yeah, this kind of a formula, you obviously don't want to panic. Otherwise, it's just going to be a mess, It's just literally going to be a mess. So this is one of those things where you just want to be able to like use your calculator, and you also want to be able to use your formula sheet, because on your formula sheet you basically do have like what you may call, you have like a formula for standard deviation. So, and it is obviously one of those rare formulas that you like hardly ever use, or rather you have a formula for what is this? Yeah, I mean, like you did I just say you have a formula for standard deviation? Well, I mean, like, it is what it is, it is what it is. So to make your life easier, right, the formula that I'm referring to is this one on the formula sheet. So if you check on your formula sheet right at the bottom, you have this formula here. This formula literally always gives you like variance. You see, standard deviation squared is variance. However, what we're trying to say is this formula is what you need. You see, it's on your formula sheet, so you don't like have to cram it, of which this formula here, we said the square root of this formula is what's going to give you your standard deviation. So let's just take this formula here and actually make use of it. Let us go back to the whatever it is that we're doing. So let's paste this formula here. Yo, not so big, my guy, not so big. Not so big, please behave. But anyways, let's see here. Let's just state that this is from the formula sheet. You see, let's see here, from where now? You do not write from anymore. Ish. Yeah, ne? My handwriting is amazing. Like, oh my goodness. Let's say here, from the formula sheet, from the what now? From the formula sheet. Formula sheet. There we go. Let it be known that this is from the formula sheet. So this squared here will always be variance. You see, this value squared is, yeah, standard deviation squared is called variance, but then this symbol here is standard deviation. You see this symbol here, so that is what standard deviation is. You see, so let's put here standard deviation. Whew, wow, man. Let's put here deviation. Very interesting. Very interesting. So this standard deviation, I mean, if you're given this kind of data, you see, this is basically asking you to get the standard deviation, or one or the other. This is going to help you get the standard deviation, because you already know that whatever you're adding up here, ne, it's giving you 6,550. So, I mean, here, the idea is, if you're going to work out your standard deviation, you need to know how many numbers you're adding up. And it is all based on this value over here, you see. So this 6,550, they are practically giving us this value over here, you see. That's what this is saying, you see. So let me actually do arrows, some funny arrow stuff, to show that this here is representing this whole thing here. So we know that in our case, since P, we worked it out to be like 85. It means that in our case here, our value for N is just going to be equal to, what is N going to be? N is just 1,000, because of 915 plus 85. Is it 915 plus 85? Yeah, let's do it. 915 plus 85, this is 1,000. So now you can throw that information into your formula, you see, because we know that the top here, it just gives us yeah, therefore variance squared, which, I mean, therefore standard deviation squared is just going to be equal to 6,520. This whole thing here, you're going to divide it by N, right, which is 1,000. So standard deviation is going to be this value under a square root symbol. Let's go. So this here is just going to be equal to, in the calculator, let us see what it is that we are getting there. So in the calculator, we're getting 2.6 if you're going to write it to one decimal place, as they said we should. Let's see here, 2.6, right? 2.6. Nice. Very nice. Very nice. We love to see it. So anyways, let's see here. Question number 8, right? Question number 8 says the following. In the diagram below, the semicircle with center A. Where is center A? Ooh, wow, this is going to be an interesting question. Questions like this They are nice, you know, they are nice. I'm not even going to lie. It says the semicircle with center A. So if it's a semicircle with this center, it just automatically means that this line is equal to that one. Let's just put that there just for the vibes. This is also equal because that's red eye. And then it says here, yeah, the semicircle with center A and diameter FAE. So where's FAE? Where's FAE now? FAE, this is that straight line, it's the diameter. Yes. And then it says here, FAE going through B. FAE going through B. It says the semicircle with center A, right? And diameter FAE going through B. Oh, so this diameter, this line here from A, it goes to B. Okay, I guess that's what they mean. It goes to B and it goes to C. They said here they lie on a horizontal plane, so they're all on a flat surface. And then they say it's a 2D shape, this one. I mean, the flat, the A, C, B part is on the ground. But then it looks as though that, yo, come on, bro. It looks as though the A, D part here, let's see here. CD is 9. Wait, CD, yes, this is 9. CAB is 110. But then here they're saying AD is a vertical pole to the plane and is 2 meters in height. So this is, all in all, this is a 3D sketch. But then C, A, B, and E and F, those are all like on the ground, you see. And then this is like popping out, going up into the sky. So it's 90 degrees. I mean, as in, it makes an angle of 90 degrees with the floor here, because that's just how this works. This is 90 degrees. This angle is 90 degrees. This angle is 90 degrees. This one is 90 degrees. Or like this, it may just be too confusing. So let's leave the 90 degrees stuff until we actually need them. Whew, okay. I guess this question really got hot now. Ha ha ha. Let's see. For 6 whole marks. Wow, 6 marks. Have we gone through a 6-mark question yet? I think this is the first 6-mark question, yeah? Anyways, they say it here, calculate the length of DB. So we should get the length of DB. Where is DB? DB is this over here. There's DB here. It's a dotted line. Let's see this dotted line. It's a very nice dotted line, this one. We should just get DB. So our focus is always try to get information to where this triangle is, because if you're going to get DB, your focus should be to get info into this triangle here. Let me just put this, let me draw this out, that, and that. Yes. So you have D at the top, right? D at the top over here. At the bottom here you have your B. And then here you have A. So A is like over there. Okay, so you see this equation, this triangle here is quite plain. You see, with 2D triangles, that's what you must do with like questions on 3D triangles. Always remember that whatever is plain, it's fine. Just make sure that you get information there. And the way you can get information here is to use things like, you know, the lines where both triangles meet and stuff. So let's see here, these two lines, I mean these two triangles, right, the ACB and triangle ADB, they meet at AB. So your plan should be to get information from the bottom here into this triangle using whatever you can. So we're given just this here. These are equal, so this should I think we can work with this. We can solve for AB using the cosine rule, because AB is the same as like AB is equal to AC. That's like a given. Let's actually maybe write that down just so that we can make sure we'll all know that it's there. So AB, we know that it is equal to like AC. And then this is given. So our task is to be able to use the cosine rule. And our plan is to actually just use AC. But then we want to write AB as AC as well. So let's see here. Using the cosine rule, right? The cosine rule, generically speaking, if you check on your formula sheet, it will tell you that a squared is equal to like b squared plus c squared, and then minus 2bc cos a. The idea with the cosine rule is that you just have to keep in mind that this here goes with this over there. You see, this is the side and this is its opposite angle. So in our case here, our a is just the 9, and then our angle there is just the 1 or the 110. You see, if you can throw those in there, you're good to go, because the rest is just going to be AC. You see? So here we can say, therefore, 9 squared is going to be equal to AC squared. Here you're going to put an AB, but then AB and AC are exactly the same. So for now, let's just do it like this, and then we're just going to write it as the same thing afterwards, after we've written out AB first, just so that we don't confuse too many people, you know. So here we can say, therefore, 9 squared is like 81, right? So this is like 81. This we can say, oh, I forgot to put the squared there. So here we can say AC squared plus AC squared, and then AC here dot AC here dot cos that. So we're writing this as AC because you see we wrote this as equal, and our task is to get a value for, oh no, why am I using AC? I want to be using AB. Yammer. I want to actually use AB instead, because AB is the one that makes better sense. So yeah, this is just me being, is this just a mistake? I want to use AB actually. So let me remove this and this, and then this and this, and let me write AB. I don't know why I kept saying AC, but what we actually need is AB. So AC, we're gonna write it as AB. AB, we're gonna write it as what it is, AB over here, AB over there. You see, so let's see here, we just have to say 81. These two added together is going to give you 2AB squared minus 2AB squared. Don't make the mistake of like canceling these two, because they are not pasted together. I mean, like these two, you cannot say this cancels that, because the cos 110 is still there, you know. This is pasted together. So you can, instead of you being able to cancel these two, the least you can do is to like take out 2AB as a you can actually take out AB squared as a common factor here. Then here you're going to have 2 minus 2 with cos 110. And then because you're working out AB, you can obviously divide both sides by the bracket there. So this, you're going to have 2 minus 2 cos that, and then 2 minus 2 cos that. And then what you have next, obviously these can like cancel each other out, right? So this can cancel this. Therefore, your AB, you can obviously square root both sides, right? So AB here is going to be the square root of this side here, because you're going to square it here, you're going to square it over there. So let's see here, 81 over 2 minus 2 cos 110. Let's see what AB is. And I see why this mark question was like out of 6, but oh, I'm wasting my space here so hard, like wasting my space so hard. But oh no, we could have actually gotten this using like the sine rule. Could we though? Ah man, I feel like such a dum-dum. I really do. But wait, why do I feel like a dum-dum? I don't know. Because, oh, we could have gotten the angle 35. Oh, snap. Isosceles triangle. We could have actually gotten this as like 35. And then this as like 35. And then used the sine rule instead. But I know, I didn't think of that. So I just thought of what came to mind first. And I mean, here we are. We're about to get AB. I mean, like, you know, it is what it is. AB here, we're getting it as 5.49. Yeah, I think we can just round it to 2 decimal places for now. AB is 5.49. So this that we have now, I mean, like, ish, yeah, just go with your gut in the beginning. Don't spend time thinking of the easiest way to do something. Just actually do what you know you can do. And then if you spot an easier way halfway through, don't worry, just carry on, you know, like legit. Like, yeah, it is what it is. It's okay. It is okay. It is okay. So we have AB now. Now we can throw it here, you see, 5.49. And then to get this, we can just use Pythagoras theorem, you see. BD squared is equal to 2 squared plus ha 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 ha. This squared just gives us, okay, that's not funny actually. Why did I say ha ha ha? My guy, you are busy laughing just by yourself. Awkward. Anyways, let's square root both sides here. The DB here is going to be the square root of this whole thing here. 2 squared plus this thing here squared. Squared. This is going to give you dB, right? dB here in your calculator is just going to give you 4 point, let's see here. How many did they say we should give to oh, they said 4 decimal places. Oh wow. Let's actually check what this is in the calculator so that we give. So if it's gonna say 4 decimal places, I reckon even the 5.549 thing might as well put it as 4 decimal places. But let's see here. Squared plus the thingy 5.49 squared ish. Yeah, I'm getting 5. Yeah, I think it's best for this kind of equation not to round off early, right? So ish, let me eat my words here and remove this and actually not round off at all actually. So let's say here AB is going to be 5.49. In the calculator it's giving us 4934 and then 856 and then it's giving us 49. So it's giving us 49 over there. If you throw that in here, let me just put squared here. Let me just put dot squared. All this in the calculator, right? It's gonna give you 5.8. Or getting 58462 like that. You see, that's your value for dB. The 4 decimal place part, I only spotted it just now, and ish is dangerous. This thing, like 4 decimal places, I feel like this is where they can chow a good 1 mark if a person like got full marks for this question, but they didn't see this. Like, wow, these guys are so mean. But anyways, let's keep moving forward. You know, it says calculate CDB. Where's CDB? Where are you, CDB? CDB Ukokaijo, where are you? Let's see. CDB. Oh wow, it's this angle here. So when you're looking at this angle here, you have to be careful. The triangle that you're actually talking about is DCB. You see, this triangle here is like the triangle that's in like the A. So this triangle here, if you're going to work out the angle over there, obviously the 9 is useful. The 5 point something that we've worked out, that is definitely useful. Might as well use it. And then it looks as though we may want to get what did they say we should get here? What did they say? They said we should get the angle. So if you're going to get this angle here, trust me, you at least need to use, it looks like the cosine rule is what's going to help us here, because us getting an angle here or getting an angle here, that's not going to happen, you know, looking at our sketch. So it looks like the cosine rule is what's going to bail us out here. That's if we get CD first. So getting CD, we can use the triangle on the left here, like this one here, this triangle over here, because this triangle over here, we have AB, right? AB, we low-key worked. Let's see here. Let's say here, no, we have AC. AC is the same as AB. So here, let's just take these two down over there and use them down there, because that's where they're going to be useful to us. Yo, space, my guys, space, ish. But it's okay. So using our sketch, right, let's see here, we have AC. AC is the same as AB. So did they say anything about, okay, 1 decimal place? So here we can actually just do 4 decimal places. It's okay. Nah, let's just do 1 decimal place. Really, 5.5? You want to use the whole 5.5 for that question? Ish. Yeah, now you see now. Hey, let's just use the 4 what? Yeah, but why am I stressing here? This is actually quite awkward. So the funny thing is, these two triangles, they're actually congruent because they have a common side, and then they have this equal to that. So I mean, whatever BD is, it's the same as DC. Like, you don't have to work out DC again, you see, because this triangle over here is congruent to that one. You see, this is the same as like 5.49. I mean, like, so even if you to use Pythagoras theorem or whatever, here you're just gonna get the 5.8462. Only that's like pure logic, you know, because this is equal to that. This is a common angle. If you use Pythagoras, same idea. Now with our cosine rule, we have all the sides of this triangle, right? Like, we have all the sides, so it's like 5.8462 here. Since we have all the sides, we just need the angle. So putting stuff into the cosine rule is like so easy, because like this is these two. You have to remember that these two here are the ones that will be where the cos is. This one, you always put it on its own because that's the one opposite the angle. So here, let's see. This is going to be like 9 squared. It's got to this here squared, 5 point this here squared. And then you're going to put the plus this here squared as well. 5.4582 squared minus 2. So remember the cosine rule, I mean, like, it's on your formula sheet, so you really don't have to like cram it or anything. You can always just get it from the formula sheet when you need it. So here, make this a bit smaller because I'm like, you know, it's a bit big now. So here we're gonna put this same number, 5. What did I put here? It's supposed to be 8, my guy. 8. 5.8462. Hey, what am I writing here? No, man, no. So you have 62 over here, and then 62 again. Let's see, the 62 again. Hi, I need more space. Excuse-moi, I'm gonna create the space for the me. Hey, let's actually maybe push it down here so that we can have space, hey? Or push it up there. Yeah. Ooh, this is so much. I pushed it a bit too far, eh? Then this is like cos the angle. The angle here is just angle D. They have labeled it CDB. Let's see here, CDB. Okay. So here you just don't need to panic, you know. You're already home free when you've done something like this. So let's just, if you're gonna work out the angle, right? I mean, like, just make life easy for yourself. Let's just take this. Let's just see what this and this is. Or normally, I don't know why I'm even like stressing and whatever here. Let's just put everything here. Let's get this number into the calculator, and then get this number into the calculator. Or what I'll do is I'll just isolate this angle. I feel like that's going to be easier for me. So to do that, we can take these two to the other side. No. Let's just do the calculator stuff, you know. Let's keep things simple. 5.8462. So to avoid this situation, to be honest, on my side, I prefer just making the angle the subject of the formula first. So to do that, let me show you. This is going to be a squared, This is equal to b squared plus c squared minus 2bc cos a. Let's make a the subject of the formula because that's the angle, you see. To do that, you see, these two go to the other side first. A squared minus b squared minus c squared. And then you're going to have minus 2bc cos a. And then you're obviously going to divide both sides by the minus 2bc here. You see, both sides you divide by that. So let's see here. No, wait, let me just do it without wasting space here. Both sides you're going to divide by 2bc. Divide, let's minus 2bc actually. Yep. And then here, I wish I had more space. This is going to cancel that. And then here, you're going to have, what you're going to have, might as well have to spill it over to the other side here. Hello from the other side. So here you're gonna have a what? A squared minus that over that. This is equal to cos A, you see. Getting A on its own, you're gonna put here cos, shift cos, right? And then A squared minus B squared minus C squared. The whole thing here with a negative 2BC equal to A, you see. So in our case, this is how you do it. You just throw all these relevant values in A, B, and C, you see. The A is the one that's going to be 9 squared. This is going to be the 5.8462. Same as that other one, you see, it's 5.8462. So all this being said, our angle for CDB in your calculator, CDB, this here in your calculators, you are getting it as 100 degrees, no, 107 degrees, no, 100.7 degrees, bro. Yo. Hi, no man, it's 100.7 degrees. It just sounds a bit weird. 100.7 degrees. Wow, that's going to be your angle there. Nothing crazy, nothing major. Let us move on to question 9. Okay, question number 5. Whew. Wow, we're almost there. Question 5. Let's see here. It says we are given in the diagram below. They said here DC. So whatever we read now, we definitely have to like check it in the diagram. It says here DC. Where's DC? DC is this line over here. Oh snap, man, snap. What is this? There's D and C. I know. Hey, I have to zoom out. Yep, that was my stomach. Me, I'm hungry like a lion. Anyways, let's see here. Erase this thing. Why am I doing all this? Like, I should just be jumping into the question, like legit. Hey, they told us that they said here this and this are tangents. So you see, that's like important. These are both equal to each other. This is equal to this. And the moment you hear things of the thing is, what are you saying? If you see that lines are tangents, always look for the 10 chord theorem immediately. Because you see, there's a tangent here. And then the idea is that you have 2 chords here. So this is the chord, so it means that this angle is equal to that one over there. Now, obviously, don't forget that here you also have another theorem. This is a radius of a circle, and this is a tangent. So this whole angle is 90 degrees. Here, you have the same scenario happening. This whole angle is 90 degrees, but you also have the 10 chord theorem. I'll even put it in red because you have to remember that this is an isosceles triangle at the end of the day. So this angle here, you see, it's still equal to that one because you have a tangent here, you have a chord over there. The angle opposite the chord, that's the one that goes with the 10 chord theorem. In this case here, it was this tangent here and then this chord, you see. The angle opposite this chord was this angle over there. So you see, all 3 of these angles are equal to each other. So that's going to be like, I think it's going to be a big deal. And one thing we can already spot is there's an angle at the center here. So this one is going to be 2 times whatever that one is. You see, because this is an angle at the center. It's subtended by like CE. This is subtended by CE as well. So there's quite a lot of things happening in this sketch. They said A is the center. Yes, we can see that. And then they told us B lies on the circle. Yes. And then it says bay is a straight line. Okay, interesting. For 5 marks now. Wow, bay is a straight line. They're dissing here right there. And I'm not going to go into details, but make up your own conclusions. It says here, prove that ABC. Where is ABC? Prove that ABC, this triangle here. So let's put it in yellow. We need to prove that ABC. Yeah, see, man, come on. ABC is there. We need to prove that this ABC here, right, is similar to DEC. Where is DEC? DEC. Well, it doesn't look like that's very hard, because luckily when you're proving similarity, always look for at least two pairs of angles that are equal. So in this triangle, we can already see that these two are equal. Fortunately, this and this are equal, right? So we know that they're equal because they are radii. So this red angle here, we already know that it is equal to that red angle over there. So that's what we're going to use to prove similarity between, let's actually make this a whole pink triangle here. So between this pink triangle and the yellow one, we're going to prove similarity using the fact that these two are equal and these two are equal to each other, you see. And we cracked this question long while we were like discussing the given expression and everything. So here, the first thing we're going to state is that we have the 10 chord theorem doing the things there. So we can just prove that E2, this is E2 by the way, E2 is going to be, let's do that. E2 is going to be, reason is 10 chord theorem. 10 chord theorem. You see, the 10 chord theorem has bailed you out once again. So we have now proven that one angle here is equal to one angle over there. Good. The next thing is we're just going to say that C3 is equal to E2. C3 is equal to E2. Reason is opposite or base angles of an isosceles triangle. I think both words work. Base angles of an isosceles triangle. You see, so we've now stated that these are equal. So far we have accounted for 1, 2, 3 being red. Now for C1, we're going to say it's equal to B. C1 is equal to B. Oh, my stomach. Come on, stomach. You're embarrassing me here. Trying to record. I'm busy here growling. Hey, I'm hungry. But I don't want to eat right now. Ek is besig, you know. We eat when we're done. Not while we're still busy. Anyways, let's see. These two are equal to each other. Why? Because of, you know, base angles of an isosceles triangle, and then AB is equal to AC. You can say that all in one go, you know. This is equal. You're going to say here base angles of an isosceles triangle, and then you can state there, what's that? AC is equal to AB. AC is equal to AB. Yes, the reason is red eye. So we have stated that all these are equal to each other, you see, because I'm like, oh no, we're only left with we said E is equal to B, so B is equal to, well, I mean, like, we may think to yourself, is this not like confusing ourselves? No, it's not. We're not confusing ourselves at all. You see, because if you think of it, right, we've said that E2 here is equal to B. So that's like one thing in one triangle and one thing in another triangle. And then we said that this is equal to E2, right? So automatically we can have a mini conclusion here where we can say, so this is equal to E2, this is also equal to E2. So here we can say, therefore, B is equal to C3, see, because they are both equal to E2. So this B here, we have basically stated that is equal to this C3 here. So we have stated that these two are equal to each other. And we've basically stated that these two are equal to each other. And one or the other, these expressions here are telling us that all four are equal to each other. Of which, that's good enough to say that two pairs in one triangle are equal to two pairs in another triangle. So hopefully all this is not confusing at all, because our point is to just show that this is equal to that, and then this is equal to that, but then one of these is equal to one of these, and these statements do exactly that. So in terms of proving similarity, we have to show that three pairs of angles are equal, so that the two sets are sorted. This last one, you're going to say it's equal literally because of interior angles of a triangle. You're going to say A1 is equal to D. Let's write here in yellow, A1 is equal to D. The reason is interior angles of a triangle, you see. And then you can then say, therefore, those two triangles are similar because you have proven that all three sets of angles are equal. You see, therefore, triangle ABC is similar to triangle DEC. The reason is angle, angle, angle. And that is the way we like it, people. That is the way we like it. We like it so much. Anyways, that's just that. Nothing crazy here. Nothing major. Let us move on. Anything that starts with hence means you should definitely use the previous question, like 100% of the time. So, yeah, let's use the fact that we're proven that these are similar. They said here, hence, show that this times that is equal to this times that. So it's quite simple. Just take your expression here, right? You know that these are similar. Oh, no. Oh, delete. Oops. I wanted to copy and then I pasted. Busy wanting to copy. Let us copy this. Danko. Copy it and paste it. So obviously, if you've gone through like the proportionality theorem tutorials, then you know that we have stated that as long as you have proven that two triangles are similar, you can write many expressions. You can write here stuff like, let's see here. Wow, this is actually quite interesting. The only issue is there's no AE that's going to be formed in any way. Wow. Oh, yeah, here we have to think creatively. Because look here, we have to really think creatively, but not too creatively, because the expressions that we can write down, it's only AB over DE. Let's write that down. AB over DE. This is equal to BC over EC. And then this is equal to AC over DC. So we obviously want lines that at least match with what they're asking. So here they spoke of EA. We don't have any EA here. But then look, EA here is equal to AC. So when we see AC, we could just be looking at that as like EA. So let me just get a purple here so the colors match. You see, we said that EA here, or AE, is the same as like CA and BA. So let's look for BA or CA. Well, there's a BA over here and there's a CA over there. So one of these could work to replace AE. Let's look for EC. EC is like somewhere here. Okay, fine. And then let's look for BC. BC is like somewhere there. And then let's look for DE. DE is like somewhere there. So obviously these two work better because there's like more information here. You see, all four of these, they are part of what you need there. So here you can then say these two here. Just take those two there. Just take those two there. These two, you can already see that if you cross multiply, you're going to have AB dot EC is equal to DE and BC there. BC and DE cross multiplied as well. So here, obviously, all you have to do is, you know that AB is equal to AE. You see, let's just write it down. AB is equal to AE. The reason is red eye because they are both the radius of the circle. So here you can then say, therefore, AE dot EC is equal to like BC dot DE. Very nice. Woo, this question was quite simple, quite simple. The next question out of the 10 marks. No. Question 10. We're like left with 2 questions now. Like, wow, this is so amazing. Let's go. Question 10 here says, in the diagram below, E lies on AB. Where is E now? E lies on AB. Okay. And then it says here, and F on AC. Okay, there's F over there. And then it says here in triangle ABC, which is the big triangle. So you have 2 lines here where they've spoken about those 2 points here that are literally on the lines. So we don't know that E and F are in the middle of those 2 lines. I mean, we could assume, but you can only assume and whatever, but you cannot use anything about midpoint and stuff until you have like actually proven it. As I'm looking at question 8, I'm in question 10, I'm like, yo, I'm so hungry, yo. yo, ejo kitswere kitlala, Joe. Like, yo, intwere, yo, I'm so hungry. And the funny thing with me is I really can't like stop doing something and like maybe go eat or something if I'm not like done, unless I'm like about to like collapse or something. But I can low-key almost feel that now. But like I think I can push through and just finish, because that's how we do. It's how we do, man. It's the way of the Taurus. It's the way of the Taurus, and I'm saying, hey, yeah, now I can make it, me. I can make it. Let's see. All these three are parallel. That's gonna be essential. And what else did they tell us? They told us that. Let's go back to the description. They said G lies on FB. G lies on FB. Thank you very much. And then they said here H on FC. Where is H? H is on FC. Where is FC? H is on FC. And then they said here FBC. Yeah, H is on FC with triangle FBC. Man, this is just so annoying. Like the wording and the H. Maybe it's because I'm hungry. Now I'm busy not focusing because I'm hungry. They say G lies on AFB. Fine. They said H on FC. Fine. In triangle FBC. Fine. With GH parallel to BC. Fine. They've given us these ratios. AE over EB. Where is AE? AE over BE or AE over EB is 4 to 5. So let's put 4 to 5 there. And then GFG over FB is like 5 to 8. So let's just keep that there. This, you can look at it as 5 if... I'm actually color coded, Actually color coded. This, you can look at it as 8. And then this, you can look at it as 5. Oh, no. Let's do color coded as yellow. Come on, man. Yellow, do the things. Yellow, once upon a time, used to be my favorite color. Like a long time ago. Yellow was my first favorite color. When I knew what a favorite color was, I was like, yellow is my color, that one. I still remember that because, me and yellow, we were tight. Anyways, it says calculate the value of AF over AC. So it's only a 2-mark question. So you really don't have to like stress yourself too much about how you're going to get AF over AC, because getting AF over like AC, yeah, it's really not difficult. It's really not difficult. So let's see where AF is. AF is this over here. AC is the big one. Oh, well, you know that these two are parallel, so you can just use this triangle here. You see the big one? This triangle A, B, and C here. In the middle, you have F and you have E. So, I mean, like, you can just use the proportionality theorem for this one, because this is like 4 to 5. So this ratio should also be 4 to 5. But they said here this is like 5. You see, so this is, if this is X, then, I mean, you're sorted with this question. Like, you're low-key sorted. Because what? Here, this is just, let's just say here, if it's AF over AC, AF over AC is the same as like AE over AB. You see, proportionality theorem. You see, prop theorem. Therefore, you can just throw in the numbers now. So throwing in the numbers, AF is X, but then AC is like X plus 5. This is go to AE, right? AE is like a 4. And then this is like AB. AB is like a 9. You see? I mean, this is actually not necessary. I don't even know why I wrote it as X and whatever. Because here you can just leave it as the ratio that you are looking for. Because the top here, we know it is AF. We don't have it. Here the bottom part is AC. We don't have it. But then they just want us to give the ratio here. Not what about the nitty-gritties and everything. So that's going to give you 2 marks. 4 over 9. Here for 4 marks, right? They want you to get CH over AC. So let's get CH. Let's look at where CH is and stuff like that. So CH Where's CH now? CH. This is CH, and AF is like this tiny part over there. So this one. This one we have to be careful here. Like I might as well put like a tiny 4 there as like an honorary 4, because you see this and this is the same as this and this. So the big idea here is we need to make use of what they told us here. They said FG over, oh wow, I didn't see that. FG over FB is like 5 and 8. So I mean the logical thing to think of is the following, you know, like let's be logical here. They told us that FG and FB is like 5 over 8. Oh, okay. Let's put it this way. Let me draw the triangle here. So we have to draw FBC. Let's do it here. Let's draw the triangle FBC over here. So, and then let's put here this over here. Let's see, FBC. You have there, whoa, what's going on here? Yeah, FBC, and then you have H and G in the middle. H here and G. So they told us that on this side here, they told us that this is just like a 5. The whole thing here gives you 5 pieces. You can cut it up into 5 pieces. But then the funny thing is, this side here, they gave it to us as like 5 and 8. So let's see here. The 5 and the 8, the 5 here, and the 8. The one thing that you can think to yourself is, this here you can easily view it as like a 3. You know, that's just how it is. You know, if this is like, if the FG over FB is like 5 over 8, it just means that this tiny piece here, you can see it as like 3. So if you have this whole thing here as like 5, and then you don't have something there, yeah, you kind of need to like just think outside the box with this kind of a question. You see, just really have to think outside the box. So thinking outside the box, what can we do, man? Well, we know that HC, let's see here, there's HC here, and let's see here. Oof. Is the boy stuck? Well, the boy is like, ish. I'm just looking at this thing and I'm like, HC and AF. The only annoying thing is AF is like all the way up here, and then our our HC is like all the way down there. Like this is where Euclidean geometry like really gets annoying, like legit. So in our case here, you may want to forget about this 5 and just worry about how this is just 5 to 3. You see, this ratio here is 5 to 3. So let's put here a 3 here with a 5 over there because of what they told us here. So because we know that, we can clearly see that the ratio between our HC, like what's the game plan here? I feel like I should pause and think about it, and then like come back with like a proper game plan, because right now I'm just like, what's going on? Like why, you know? Let's just pause and think about it. I have thought about it. So the only thing that's missing here is like, you know, variables and stuff. So you see, when things are a bit messy like this, nah? Like how here you have a 5 and a 3, and this is representing 8. You have a 5 and a 3, but this is representing a 5. What you do is, because this 5 goes with the big triangle, you see this big triangle here, this 5 goes with this 5, this 4 goes with this 4. It's for the big triangle. So you can label these here with a K so that you know that they're basically going together. So here I can put this with a K here as well. Now what I want to do is, you want to have a way that you can work with this right side here and this left side here, one way or the other. So what I mean by that is, if you write out a ratio between like HC and the whole line over here, what you can write down here is that technically, you know that they told you this here. What did they tell us? FG and FB, yeah, they have that ratio. FG over FB, this is equal to like 3 over 8. And it is also equal to like wait, let me write it flipped over. No, let me just not write it. This is going to be like FH over like FC, right? So the only issue is, I mean, like, instead of us focusing on like FH, we want to focus more on like HC. So in terms of us focusing on like HC, oh no, I wrote them incorrectly. No, I'm mixing. Oh no, I'm messing up. I'm sorry. Don't kill me. Sorry. FG name is 5. FB is 8. So let me write it like, instead of writing it like this, I want to focus more on like writing an expression that is HC over there. So let's start off by doing this. Let's say HC over FC over FC, right? This is going to be equal to like BG, right, over FB, you know, because we're trying to talk about the small one with the big line over there, small one with the big line over there. So for our case, we can already see that where HC is, we know that we can put a 3 over there. But then if we're talking about FC, instead of us putting the 8 here, we can just put 5k, because this 5k here is talking about this 5k that's going to go with like the big triangle. So let's put here 5k. And then here BG is like a 3. And then here FB is like an 8. There you go. So this is like your first what you call your first this is the first thing you're going to do. So obviously here for HC, I mean, I think for HC it's actually best to not have any variable there or any value there. The reason why it's best to not have any value for HC is because you want to eventually end up with an expression where HC is going to be on top as a variable with AF at the bottom as a variable. So this expression over here, you can just cross multiply to have HC on its own. HC on its own, this is going to give you 15k over 8, right? So you have a value for HC now. That is in terms of k. You see, your task was to get HC in terms of like this k here, this k factor. So the good news is you can literally now just write out the ratio HC over AF. So here you can then say, therefore, HC over AF, what you know is AF, you already have it in terms of k. You see, AF, you know it's already 4k. So you can put here 4k at the bottom. HC, you know it's just 15k over 8. You see, because the idea is if you're gonna have a line somewhere here and you want it to like mix with something way out in another triangle, just try and find a line that is in the big triangle that you're dealing with, and then write that line in terms of like k or any variable that is linked to this one. And then whatever we did here, right, we made sure that we have an expression for like HC, but then that expression of HC, we linked it in some way to like this big line here, so that eventually we could be talking about the big triangle. Now here, simplifying here, we can just use normal, it's just normal algebra here. So on the number side, this divided by this, you're gonna have HC, right, over AF. This is equal to 15k over 8. This is technically divided by 4k over 1. And then you're just going to flip and multiply. So let's see here. HC, AF, you're going to have 15k over 8. This is like 1 over 4k. The k's are going to cancel out. And the numbers at the bottom, you're going to just say 4 times the 8 is like 32. 15 times 1 is like 15. HC over AF. Okay, yeah, this is when this paper really got hot. It's really got hot, you see. So I think my mistake was not putting the k's here the moment we saw that we were given another ratio, you see, for like another triangle. Anytime you're given another ratio for another triangle, if you're going to label its numbers, use variables for it. Yeah, it will help you. Like here, the FG and the FB. You see, it was 5 and 8. I mean, 5 over the whole 8. So because there was another 5 over here, that 5 you had to represent it with the K next to it, so that you see that it's for another triangle. Same with this 4. It's for another triangle, so you just had to put a K factor there. And anyways, that is that for this question. Let us move on. 1 mark no. 6 mark question again. Wow, man. Like, oh wow. Yes, like, oh damn. Okay. Let us hope that this 6 mark question goes quickly, because some of us need to finish and go eat because we are hungry. We are hungry. I don't know about you, but I mean, I'm hungry and I didn't bring any snacks. So, ish. Plus, I can't be snacking while making this. Like, legit. I mean, imagine they are busy talking. Nah, it doesn't make sense. It doesn't work. So, anyways, let's see. In the diagram below, they said A is the center of the circle. A is the center of the circle. So, A is the center of the circle. Yeah. Looks like this test had a lot of easy sketches, A is the center of the circle. Already we can see that this is equal to this. Red eye, this angle is going to be equal to that. That might help. This is equal to all 3. This is equal to those 2. Yeah, it's just many things. And then just before we even read the rest of the thing, it's so tempting. Like, so many things here. This is going to be double that one. And this is the diameter of a circle. So we have a 90-degree angle over there. Hey, yeah, it's popping. This sketch. It says A is the center of the circle. Yes, we can see it. And then they said there, BCD. Where is BCD? B, C, D, and E lie on the circumference of the circle. And then it says here DAB is the diameter. Yes, DAB is the diameter. That's all they gave us. So you see, all that we were putting for ourselves, that's like useful information, because I mean, like, you know, we kind of need to know all that. For 6 mark here, for 6 marks, they said you should prove that A1, where's A1 now? Ooh, A1 is over here. Arch. They said we should prove that A1 is equal to 90 degrees. Okay. Minus E2. Where is E2? There is E2 there. Plus B1. Where is B1? B1. Yo. Hi. You know, for questions like these, this is like a weird proof. So, to be honest, with a proof like this, the best you can do for yourself is to, like, yeah, just keep it simple. You know, don't overthink it. Just keep it simple, in the sense that you just want to look for angles that are equal to whatever they're talking about, or just use your theorems. Let me actually stop talking and just actually start acting. So here they say we need to get an expression for A1, right? Yes, but then if you think of it, right, we know that A1 is going to be, the first thing that stands out is that A1 is equal to these 2 combined. That's like, bluntly speaking, A1 is equal to those 2 combined. Furthermore, if we're going to incorporate 90 into, like, our expression, like here you see A1 is equal to B1 and C2. So let's just start there. Actually, let's just start there. B1 is equal to C2. The reason is base angles of an isosceles triangle. Secondly, you're gonna say that therefore A1 is equal to 2 times whatever B1 is, because it's just like, let me actually write it bit by bit so that we don't, like, freak out anybody, you know. This is equal to B1 plus C2. Your reason for stating that is, what is your reason again? Exterior angle of a triangle. Exterior angle of triangle. There you go. So here we're gonna have to say therefore A1 is 2 times whatever B1 is, because these 2 are equal, you see. So we're gonna write it as 2B1. So now we have A1 and some B1 in an equation. Now we need to some way get this into the equation as well. So the one thing it looks like the one thing we can use here is E1 and E2, because E1 and E2, those are 90 degrees. So that's a way we can incorporate this thing here. Let's look at where E1 is. E1 is definitely half of this A1 over there, you see, because of angles at the center of a circle. Angle at the center of a circle. You see, this here is double whatever that angle is, because angles at the center, angle at the center of a circle is equal to double the angle at the circumference. So let's write that as A1. A1 here is equal to 2 times whatever E1 is. The reason is angle at center of circle. But then the only issue is we specifically would want to, what would we want actually? Yeah, I mean, like, in as much as this is useful to us, we actually, I don't think this is very useful to us actually. Yeah, that's not very useful to us, because we want an expression for, no, is it useful to us? Hey, yeah, you see this thing, this thing, like, it's just like, you see now, no, wait, I think we can use, hey, yeah, this is not fair at all. Like, this is not fair at all. Like, this is not fair at all. Like, why? Why are you doing this? You know, like, why in the world are you doing this? Hi, yeah, oh, wait. If you look at it, B1 and E1 are equal to each other. I think that's what you could actually do. Instead of writing this here, right, you could just write there, instead of writing this here, you know that B1 and E1 are equal to each other. Let's state that. We know that B1 and E1 are equal to each other. Reason is, how? Yeah, angles subtended by the same arc. Yeah, so let's write that down. E1 is equal to B1. Angles in same segment. Angles in same segment. So because E1 is equal to B1, let's see here. This one is going to be, well, this is technically B1 plus B1. Let's actually write this as B1 plus B1. B1 plus B1, so that we have at least one B1 here. So this other B1, we're going to change it to E1. So here we can then say, or before we change it to E1, let's write out an expression for E1 in terms of 90, because E1 plus E2, that's equal to 90, because angle in semicircle. E1 plus E2, that's equal to 90, angle in semicircle. Angle in semicircle. And then now here we can say, therefore, E1 is equal to E2. No, 90 minus E2. Because we just, just reshuffled our equation. So where we see B1 here, we can just throw this one here. Because you see, we have proven that B1 is equal to E1. E1, we know it's equal to this value over there, you see. So that is where we are going to end things off, you see. So here we can then say, therefore, A1 is equal to, when we see B1 here, we said it's equal to E1. You might actually use arrows. Where we see E1 here, we said it is equal to this thing over here. So that's why here where we see B1, we're just going to throw there 90 minus E2 plus B1. This is the dumbest proof I've seen in like such a long time. Not dumb because it was easy, it was just like so useless. Like, what the hell, man? Like what? This is just like such a weird proof. But let me not judge. Let me not judge. It was just a weird one, kind of difficult-ish, but not crazy. But anyways, let us keep it moving, huh? Look at this. We are literally at the second last question. Like, finishing a paper, it's something that you can never get used to. It's such a satisfying moment, Like for 6 marks here, full 6 marks again. Wow. Yo, another dumb weird proof. Hey, let's not judge, It says in the diagram below, hey, yeah, these IEB papers, you see, y'all get easy stuff. Let's CD. Yo, why do I sound so mean now? How? It's not easy. it's just a normal quick paper, just like 2020. Both also the CAPS paper was easy, so let me not judge. It says here CD and BE, right? Accords with CD equal to BE. Yes. 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 They told us. Then they said F is also a point on the circle. Yes. So in this circle, we kind of have two cyclic quads, you see. There's a cyclic quad over here. And then technically there's a cyclic quad over there. So then don't forget that, It's quite an interesting sketch, this. And then it says here F3 is equal to X. So where's F3 now? Over there. They've labeled this X. Okay, fine. All this being given for 6 marks, they said we should prove that C2 plus C1, which is, let's color code it. So in my opinion, just thinking of this question, they said we should prove that C2 plus C1 is equal to B1 plus B2. B1 plus B2, like that. Wow. I feel like the one way to do this is you're probably going to use the whole cyclic quadrilateral stuff that we just spoke of. And it looks like you're also going to need to make use of things like what? Things like angles subtended by the same chord and stuff like that. You see, angles in the same segment, yada 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 yada. That's basically what's gonna bail you out in this kind of equation. So don't overthink it, ne? Because if you overthink it, you are going to cry, Don't overthink it because you are going to cry. So let's keep our life simple and use our cyclic quadrilateral laws like we said. So here, the one thing you can safely say is because they are talking about C1 and C2 split up, try to talk about these other angles split up as well. As in, don't refer to like this big thing as like F, or don't refer to this thing here as like D, F, B. You see, you're gonna get yourself confused. So just try and follow their trend there. So for example, you see these two pink ones here. You can add them to F1 and F2. So let's see here. C1, let me use color coordinate, my guy. Color coordination. So here we say it's C1 plus C2. This is obviously equal to F1. No, it's not equal to each other. If you add it to F1 and F2, if you add it to F1 plus F2, this should be equal to 180 because it's opposite angles of a cyclic. Ooh, wow. The acyclic part. Hi, it looks bad, eh? Bad. So opposite angles of a cyclic quad, This is strange. So here it says now, the next line, it's not very difficult, this one. It's just going to be B1 and B2. So here we can safely say that B1 plus B2, which one is this one equal to? This one is equal to F2 and F3. I mean, add it to F2 and F3 gives you 180. This plus F2 and F3, this got 180. The reason is the same, right? Opposite angles of a cyclic quad. Yeah, these IEB proofs. I don't know, lie, eh? They're just weird, but it's okay. Let's not judge. I hope I'm not making enemies here. I'm not trying to make enemies. I'm sorry. I'm literally hungry. So, like, when I'm hungry, I cannot be held accountable for the things that I say. And then you're like, wait, but what are you saying? Are the things that you're saying true? Okay, fine. If it's mathematics, that can be there can be an exception for that. Anyway, so these are both equal to 180 degrees, right? So the good news is, make use of this here. This is obviously not there for just playing. You can only see that these are equal to each other. F3 is equal to F1. You see, so when you see F1 here and when you see F3 there, they are equal to each other. You see, so make use of that piece of information. Angles in same segment. You see, so here you can then say, technically just means this plus this is the same as this plus that. You see, so here you can then say, yeah, from here you're almost like home free, because I mean, like, if you've proven that this is equal to this, then I mean, like, you're so done, Like you're so done. Because you have technically then proven that this whole thing here is equal to this whole thing here. You see? So if they were to both go to the other side, it means that this would be equal to that. So here let's just say therefore C1 plus C2 is equal to 180 minus these two. This whole chunk, if you take it over, you can write it like this. And then here also B1 and B2, if you take this whole chunk over, it's going to be 180 minus F2. Let's actually write it. Let's write this as F1, you see. F2 plus F1. You see, they are both equal to each other because of the right hand side here. So here we can then say therefore C1 plus C2 is equal to B1 plus B2. But if the brackets bother anyone, let's remove them. Let's just remove the brackets and then just put minus signs there, just so that people don't complain like, oh, you did not change it to a negative. I had the brackets there, But anyways, let me just put this minus and this minus here just to show that everything here went to the left, everything here went to the left. But then these are equal, you see. So where I see F3, I can just write that as F1. And then you're done. Another weird proof solved. Let us keep it moving. Ooh, another sketch. Ooh, it's a star. We love stars. Stars make the world go round, I think. No. The quadratic formula makes the world go round. Well, many things make the world go around, actually. It's not just one thing. Oh, we have a YouTube comment. What did they say? Oh, nothing. Okay. In the diagram below. FB. Oh, there's a lot of lines here. Yo, these diagrams, though. They say it here. FB and CD. Where's CD? CD and FB are chords that intersect at H. And then it says here CB, yes, and ED, yes, are chords that intersect at A. Okay. So if they give you points where two lines meet and stuff like that, yeah, that point is usually important. Like here, you see, they haven't given you any of these, so don't ever think they're important because they have not even given them a name, And then it says here BCD is 30, so this angle here is 30. Okay, thank you. Hey, might as well highlight it. Might as well write it nicely, like 30. And then the other one is like 45. So this one over here is 45. Use a blue maybe. Totally different color. 45. And then what you got? They said here GB. Where is GB? GB is this pink one here. GB is this pink one here. They said it is a tangent to the circle at B. So you have GB over there. Oh, no. Yes. GB here. They said this is equal to 65. Okay. They said it is a tangent to the circle at B. So 10 chord theorem shandy is here. Like legit. Just do the 10 chord theorem stuff before you forget about them, So let's get like a bright color here, like a red. I want a red, please. I wanted I think a green is okay. Now let's do red. So this is the 10 chord theorem. It looks like there's a few things here. Oh wait, do we have the 10 chord theorem? No, we don't actually. The reason why we don't have the 10 chord theorem is because we don't have a triangle that is part of this line here. We don't have a triangle where this is one of the sides and all three angles of the triangle are touching the circle. We don't have the 10 chord theorem anyway here, unfortunately. Or do we? Quite interesting, right? Quite interesting. Actually, we do. No, we don't. We don't, unfortunately, because this does not draw any triangle that comes back here. You see, it just goes there, doesn't come back there. It just goes. Yeah, we don't have a 10 chord theorem here, so you can't forget about it, unfortunately. With all these, they said we should get F3. Hey, maybe we might find the 10 chord theorem somewhere. I don't know. But me, I'm not holding my breath. That was just weird. Don't even know why I did that. But anyways, let's see here. To get F2, how many marks was this question? This was actually a 6-mark question. Snap, I forgot to show the 6-mark thing. I'm sorry, I guess yammer. It was a 6-mark question. And with a question like this one, this is one of those questions where you really do want to make your own construction, because if you don't make your own construction, this sketch is not going to make any sense at all. So hey, let's do it, let's do it. So here you're going to need to make your own construction. Construct. The one thing that makes sense to construct is something on the 10 chord theorem. And you may be asking, how do you know when to construct? You make a construction when you see that your sketch seems as though there's not enough information given. Like as we said, there's no 10 chord theorem scenario playing out and all that. There's just nothing. So the best thing you can do is to create your own 10 chord scenario, which is drawing this line here. So let's construct EB. The reason we've constructed EB, well, you can construct any other line really. Let's actually construct another line, just so that you see it really doesn't matter which one you construct. So we said our main focus is to at least try and construct something where the 10 chord theorem can be applied, you see. So let's not do EB. Let's do another line like this one, because I'm trying to emphasize the fact that it really doesn't matter. This one is easier. This one makes more sense, because at least now you know that this is an angle inside this triangle. So this chord here, you see, it's opposite this angle. So if you're going to think of the 10 chord theorem, you already know that this angle down here is a 30. So here we've made this construction. Let's construct here BD. So let's say here BD. We have constructed BD. Apart from constructing BD, we know that what do we know? We know that this is like 30. Let's call it 30. So here we can say DBG, DBG, this is equal to like 30 degrees. The reason why this is equal to 30 degrees is because 10 chord theorem and our construction as well. But we're just going to say 10 chord theorem now, you see. 10, the chord, the theorem. Let's just say 10 chord, because we are out of space. But hey, let's just, we don't even have to write the theorem word part, because like it's really not necessary. So what are we trying to do? The funny thing is, I literally forgot what we were trying to do, and then now I'm like, what's next? So to be honest, I'm like so tempted to do like the 10 chord theorem again, but then doesn't that then make F2 equal to like 30 as well or something? You see now this thing here, because if I had constructed like a D, oh no, DF would not work, because DF would be cutting F. Okay, fine. I think we do have to make another construction though, do we? No, not really. If I had made a construction, okay, let's see. If I had made a construction over there, I think one construction should be enough actually. Yeah, I think one construction should be enough, because I mean, like, why not, why not? So or is it enough? Hey, I don't know, man. I don't know. I really do feel like making another construction, because I really do feel like I don't have enough information for some odd reason. I really don't. This is 45 and this is 45. Oh, zigzag butterfly effect things. Yeah, I see these things. They're kind of hard to spot, but we can see it. This is 45, ne? Angle subtended by the same chord. Angles in the same segment. This is like 45. This angle here is also equal to 45. So we can say there, what is that? FBG is equal to 45, which is, yeah, it's equal to E. Let's say equal to E first and then 45. You see, equal to E, and then this is also equal to 45. The reason is angles in same segment. Angles, oh, come on, man. Angles, oh, come on. Angles in same segment. Segmente. Nice. Whew. So here we can just put a 45 there. You see, so now we have interior angles of a triangle now. We can now say FB. No, F2 is going to be equal to 180 minus these two here. That's like 45 and 30. So it's like minus 30 minus 45 minus 65. Ooh, come on now. Come on now. Then this is going to be equal to F2, right? F2 here. If you put everything into your calculator, this is just going to give you 40 degrees. Whoa, wow. I'm so glad we're almost done. Like, we're literally moving on to the last question now. Like, look at it. It's so amazing. So let us do that. Whoa. Question 12. The last question. It's been a long journey. It's been a long journey. Like, oof. I don't lie, eh? It's been such a long journey and I'm so hungry. So hungry. It's like the one thing I've been saying so often over and over again. But hey, let's finish quickly. Question 12. In the diagram below, where to be honest, it feels as though these IB papers have like more trigonometry, but hey, it's actually not true. It just feels like it. It says here in the diagram below, A and B. So you have A and B are the Y and X intercepts respectively of the line Y is equal to something. Okay, so the equation of this line is just Y is equal to negative 2x minus 6. This doesn't make any sense. Let me see. A and B. Oh no, let me zoom in. Oh, it's a plus. Oh, I was so scared. I was like, because the y-intercept is a 6, you see, because of the standard form there. So it didn't look like a plus. I was like, snap, it's wrong. Nah, how can it be a minus? So that's the y-intercept because of the standard form of the straight line. And then it says the AB and BC are tangents. So this is equal to that. They are tangents to the circle. Nice. And then there are tangents to the circle right at P, okay, and T respectively. Yes. Okay, for 3 marks, they say determine the equation of the line passing through P. Okay. And the center of the circle. Wow. So the center of the circle is like somewhere there. So this is the line that they're talking about. The good news is, you know that this is the radius of a circle. So if you're going to get the equation of this line, it's quite easy. Because you're going to use the gradient of AB to get the gradient of this blue line over here. So you may be wondering, what do we name this? You can name it whatever you want, there's A, B, and C here. So you can even label this D if you want. So let's see here, the gradient of PD, if you multiply it with the gradient of AB, we know that this should equal to a -1 because those are perpendicular lines, you see. This is what you need to do. Now we just need the gradient of AB. AB, we know it's -2. It's there. It's given. You see. So here we can say, therefore, this is just PD times a -2. This got to -1. Divide by -2 on both sides here. Let's do it. Divide by -2 here. Divide by -2 here. The gradient of PD is equal to -1/2. You see, we have the gradient now. Now we can just use our normal straight line formula to get the equation of the straight line, because if we're going to get the equation of this straight line here, we can use this formula. You see, y minus y1, x minus x1. Yeah, it feels like this paper, they really did not know what to ask, because it seems like they're just asking the same things over and over again. I feel like, to be honest, my honest opinion about this paper is that, it's boring, Kidding. This is weird. It's just like how, but we just did a question where we used this equation. Like, now we're doing it again. Hey, let me know. I'm not bad mouthing anyone that like set up this paper, if that's what you ask. I'm not bad mouthing anyone. So this is like x1. I'm just giving my honest opinion because I'm hungry. You see, I'm hungry. I'm probably angry as well. I don't know. This is -1/2. This is like x is x. The -1 is going to be a 2 again. And then you're just going to multiply inside. Y is going to be it's going to be stuck on its own. This times the negative, -1/2 times x. And then negative half plus times negative 2 is like a negative positive 1. And then the 2 comes over. This definitely does look believable. Like legit. It's just a coincidence that this is like 3, which is like half of the 6 over there. This is clearly not to scale, as you can see. But it doesn't make sense. This cannot be equal to 3. I know I've made a mistake here some way, somehow. I know I've made a mistake because this... Oh, no. Wait, what? Yeah. Because the y value of this line technically has to be below 2. So I have to double check what I did wrong here. Gradient is... Oh, no. What just happened? Oh, no. Oh, to the no. This is a negative 2. Oh, it's a positive a half. I'm sorry. You probably spotted it, and I'm spotting it only now. So, excuse me. This we multiplied inside. Yeah, thank goodness this is there to help us. Because, yeah, your theory will always bail you out, as we have just seen here. Theory bailed me out, and I wrote a negative 3. So many mistakes in one go. Yeah, this is how you know the boy is really hungry, eh? And I know you're probably thinking, bro, why didn't you just pause and go eat and stuff? I told you already. I explained, Let me just finish. I'll try not to make any more mistakes, I promise. So let's see here. This is just going to be a negative 1. Is it really a negative 1? Doggoness. You see now, let's see this multiply inside. This you multiply inside. A half, yeah. So when the negative 2 comes over, it's going to be a plus. So it's like, oh, okay, plus 2. And then here, it's going to be like plus 1. This makes sense because the y-intercept here is definitely, it has to be smaller than a 2 there. So don't just leave answers in J. Just always double check them. Here, there is like a dumb blunder. And you saw, there's nothing edited here. You saw all the blunders. So don't go into the exam hungry here. I feel like this is why I should carry on. So that you'll see I might potentially make some really serious blunders here. Just because I'm telling you I'm like literally hungry right now. And I'm going through this, you see. So it's not a good idea. I'm literally doing it just for what? For experimental purposes. Do not try this in the exam. Do not try this at home. At home. Calculate the minimum distance from the circle circumference to the x-axis. Minimum distance from the circle circumference to the x-axis. Yo. What a wow, man. Like, and it's a 7-mark question. You see this thing now. Questions like these, they just make me wonder that, like, what in the world do these guys want? And I did say this is the last question, but it's not. There's a question 13, people. A whole question 13, and I'm busy here like, oh no. Why? Okay, where are we? This is a B, right? So with B, you kind of do need to think outside the box because, I mean, like, yeah, it's just one of those questions, it's just one of those questions. So, what you gonna do now? Yeah, excuse me. So, to be honest, this is one of the questions where it's like, yeah, these are just hard, eh? Works. I guess they have these really weird, tough questions at the end. IEB papers. I know in the beginning I started off energetic, what. And I'm busy talking when I should be figuring this out. Okay, let's see. Calculate the minimum distance from the circle circumference to the x-axis. I mean, visually speaking, let's look at it from like a visual perspective first. So if you think of it, this is the x-axis, and like if you look nicely, I mean, like one way or the other, whether we like it or not, the best thing we can do for ourselves here is to get the center of the circle. The reason why I think it's best to get the center of the circle, firstly, if you get the center of the circle, we know that whatever this is, this is the radius of the circle. They said here we should do what? Calculate the minimum distance from the circle's circumference to the x-axis. The lucky thing we can do is let's just get the radius of the circle here. Because if you get the radius of the circle, let's get the radius of the circle and the what you call the y value of d. Because if you get the y value of d, I mean, like, logically speaking, like, this is not even a difficult question. Logically speaking, the smallest distance between the circle and the x-axis is this distance here. You see, this is what we need to find. You see, this is for b. This is the minimum distance. Let's say here, mum distance. You see, so our task is to just get the radius and the y value of d, because we're just going to say the y value of d minus the radius gives us that small space there. So we just need the equation of the circle, which is quite simple, I hope. Or is it? Yeah, I think so. Really though? Yeah, well, let's see. Well, we have the equation of the line there. The only issue is like identifying like the x value of d or something. So that's gonna be quite a mission, huh? It is going to be quite a mission. I don't want to lie. What you do here? What you do, my guy? What you do? Okay. Yeah, kind of need to pause and think about it, like, legit. Hey, so here I'm gonna have to eat my words here and say, yeah, ne? This is where, you know, the thinking is like a bit intricate, and it is what it is, man. So for us to get point D, right, which is going to give us like the radius and then all that stuff, we need to think logically here. You see, we have to just think logically, in the sense that if you look at this question nicely, right, let us do this point here. If you trace it towards point D, this is 90 degrees, you see, because it's a angle, it's a point of intersection between a radius and a tangent. So I mean, if this is 90 and this is 90, I mean, this makes this like a cyclic quad. Intricate, right? Exterior angle of a cyclic quad is equal to the opposite interior angle. So if this is 90, it means that this also has to be 90. And then if this is 90, I mean, like, if this is a cyclic quad, then these two both have to add up to 180, of which, if this is 90 and 90 already, for this to add up to 180, this has to be 90 and this has to be 90. The point I'm trying to make is that one way or the other, ne, this line here, there, is parallel to that one. So the gradient of this line is just -2. So let's say here, let's get what we're going to do now. We're gonna get the equation of line dt, and then we're gonna equate that equation to the equation of line dp here, which we got in the first question. So let's get the equation of like dt. So equation of dt, we can start off by saying y is equal to mx plus c. So y, let's get dt here. dt, dt, we're working with dt. Let's just put in thingies here, show that we're working with dt. dt is what we're doing first, right? Let's do it here. Come on, shrink when I shrink. Y is equal to mx plus c. The gradient of dt, we know it is equal to -2. You see, because it's parallel to this one. Luckily, this is analytical geometry, so you don't have to like put funny reasons and stuff. So in terms of finding the equation of this line, we can throw in a coordinate that the graph passes through. So this is x1 and this is y1. So here we can say y minus y1, which is just this one here. Let me actually write down the formula first, just so that on the memo everybody can see what has happened. Y minus y1 and then x minus x1. So this is like what? This is like y minus y1, and then gradient is like a -2, and then there's a 5 here, you see, because there's a 5 and a 1 there. Simplifying, let's see what you're going to get here. Y is equal to like -2x plus 10 plus 1, because you're multiplying this, multiplying that, and then here y is equal to -2x plus 11. So equating the two graphs, you're going to get the point D, you see, because you have the equation here, you have the equation here, you're gonna get point D. So let's see here, therefore negative 2x plus 11, this is equal to the half x plus 1, which is this equation over here, you see. So solving for x here, we can just see 11 minus 1, and then we have a half x plus 2x. This is like what? 5 over 2x, yes. It's like 10. And then obviously here your value of x, let's see what you're gonna get. Let's see what you're gonna get. So the x value there, it looks like, wow, man, this is such an interesting x value. Like, is this x value really like a, oh no, I made a mistake. No. Did I? Oh, snap, did I? Oh no, this is just going to be a 4. Yes, because 2.5 goes into there 4 times. So we have the x value of D. The y value, we can just get it by subbing in into n of the equation. So let's sub into this one. Gonna throw a 4 there. Gonna get, what you're gonna get? 8, negative 8 plus 11, that's like a 3. Whew, so here we have D now. This is moving along so nicely. But again, yeah, this was quite an intricate question. I'm not even gonna lie. This is where IEB shows its true colors. But hey, I'd say 95% of the paper, you see, it's all okay. It's good practice, really, this kind of a question. So anyways, so now we have D, right? It is the x value, we got a 4. The y value, we got like a 3. We got like a young 3 over there. Our task is to just work with the y value. So this is like a 3, ne? So the whole distance here is a 3. What we can do is to remove the radius to get this green part. So the radius of our circle, we can just work out the distance dp using our distance formula. So let's do that. Radius, which is just dp, put here in brackets dp. This, using the distance formula, is just going to be this minus that, and then 3 minus 2. You see, you don't have to do anything fancy. Just use the normal distance formula. So we're seeing here, what are we seeing here? 4 minus 2. Let's see here, 4 minus 2 squared. And then we're seeing there 3 minus 2. 3 minus 2. And then squared. This is going to give you square root of, this is going to be 2 squared, which is like a 4. 1 squared, which is like a 1. This is like square root of 5. This is like PD. Whew. Now we can safely say the minimum height. Let's see here. Minimum height. Yo, is this? Yeah. Minimum distance from x axis is going to be equal to 3. No. Yeah, 3, which is the whole distance here, minus square root of 5, which is the radius. Minus square root of 5, you see. And you can just leave it like that, because I mean, like, yeah, it really doesn't, if you want to write it as a decimal, it's going to be like 0.8 if you round it to 1 decimal place. But I think that's just, it's not necessary, you know. So you can just leave it like this. And yep, yeah, I will accept this question is not very simple. It's not very simple at all. But hey, let's move on to the last real question now, because hey, this one is not the last one, eh? Question number 13. I am excited. Question number 13. I am excited. Question. Okay. Let me celebrate, okay? Like, come on, man. I know you want to finish too, but let me celebrate. You know, I mean, I'm hungry and I'm about to finish so that I can go chow, you know. I'm excited. Anyways, question 13 says, a teacher creates 2 circular areas in her classroom, or for toddler A and toddler B. Wow, I won't lie, ne? This specific question, I remember doing it, or I remember going through it. Yeah, I remember going through it. I remember going through it in the analytical geometry course on like the course platform. Like this question 13 over here, like legit. Like Yeah, question 13, if I remember correctly, this is one of the questions that I threw into the analytical geometry course. So basically, oh come on bro, what you doing? Basically what I'm gonna do, I know I'm doing this because I'm hungry, like legit, like a lion. Legit, what I'm gonna do now is this question. I'm just going to take a clip from let's see, I'm just going to take a clip from the course platform, like for the analytical geometry course, and then I'm just going to paste it here in the editing of this video so that you see how it is we do things on the course platform. You see, it's exactly just like this. So with this kind of a question, I mean, it's, let's see where it is on the course platform. Let's go to the course platform here, and let us go to the Brightung Brains thingy, the course platform. Well, here okay, let me just go to the home page. You see, for you to go to the course platform, you can just search for Brightung Brains on the internet. So here, let me actually just sign out. No, let me not sign out. I'm logged into a profile here. So if you check like on the analytical geometry course, let me just go to my dashboard here so that I can go to the analytical geometry course, and then I'll insert the video in this video so that you can, like, you know, yeah. Analytical geometry should be like the second one. Let's see here. So in the analytical geometry course, what you will note is, obviously, you know, you have different chapters and everything. So this is a question where there was like no circles given and everything. So it should be in chapter 2, this question that I'm referring to. Chapter 2, he says questions without sketches given. So let's see the question here, showing that two circles never touch. I'm assuming it's literally this one here, because here, this question, right, if you look at our question, they spoke of it says here a toddler, it says here that as teacher creates two circular circles in a classroom for toddler A and toddler B. The area of the first toddler is modeled by this, the area of the second toddler is modeled by this. A teacher claims that the playing areas will never touch or intersect. Is the teacher's claim correct? So this is proving that circles never touch. You see, it's the first lesson in this analytical geometry course, because remember, with the analytical geometry course, it's basically a scenario where the course is basically giving you an idea of like how to answer specific generic questions about that specific topic at like exam star level and everything. So the snippets and some of the questions are specifically from like past papers where we would have like vetted out to see which kind of past paper questions are like, you know, very intricate and all that. So here, if you see this video here, if I open it, you can already see it's going to be giving you, it's you can see it's the same question here. So this video here, I'm just gonna slot it onto this portion of the full video, of this full recording, and then yeah, you'll just watch that. So for now, I'm going to start with question number B, because that's like something totally different. But anyways, yeah, let's go to question 13 and let's watch it, or you watch it. Like, I think you get the idea. Ha ha ha. Okay, chapter 2. Welcome. So yeah, I hope you went through the chapter exercise from the previous chapter, because that's like super duper important. And obviously the memo is under that video so that you can mark and stuff like that, or rather the memo for the whole course is attached. So I hope you downloaded that. So yeah, anywho, we are here working with questions that don't have sketches given specifically. So these are cases where we will maybe have to draw our own sketches first and stuff like that. But anywho, let's see here. We have a question here that's talking about a teacher. It says a teacher creates two circular areas in her room for toddler A and toddler B. So remember, this is analytical geometry after all. So you do have to analyze the questions. So yeah, toddler A and toddler B, she creates two circles for them. And then it says the area is, the first area is for toddler A and is modeled by this. Remember, this is an equation of a circle. It's not in standard form, it's just in another format. This one, it says here, the second area is for toddler B and is modeled by this. You see, this one is in standard form. You can clearly see the center here. However, the square root of this value is your radius. You remember, always be careful, because if this value is not squared, the square root of this value will always be your radius, as we discussed in the first chapter. So here now it says the teacher claims that the playing areas will never touch or intersect. Is the teacher's claim correct? Okay, so even before diving into this, let's see the mark allocation. It's out of 5, so yeah, nothing crazy, nothing hectic. We just need to keep calm here because, I mean, a 5-mark question is just good marks. Yeah, so let's see. If these circles never intersect, well, let's just see here. We need to keep in mind that if we had a circle somewhere here, and then we have another circle somewhere there, we know that these definitely intersect. But obviously, if you had one here and another one there, I mean, those don't intersect at all. So the funny thing here is, how do we determine whether circles touch or not? Now, don't put yourself in a situation where you maybe want to solve these equations simultaneously. That's not the way to do it. That's just going to take way too much time. And you see, there's no method to that. There's no system to it. It's not intricate. So simply put, the easiest way for you to double check if these circles do intersect, just work with the radius and the center of these circles. What I mean is, if you have a circle here, let's actually draw a circle nicely. If you have a circle over here, kablamo, and you have another circle somewhere here. Well, let's make this one a bit bigger to show that they have different radiuses and stuff, you see. So you see, you have 2 circles here. Now, what you want to recognize about these 2 circles is that they both have a center and a radius. You see, the center for this one is like somewhere there. The center for the other one is like somewhere there. So even as I'm explaining this, if you have figured out the question, you might as well pause and try it out yourself so that you can just mark using the memo. So obviously, determining if these 2 circles intersect, you only want to compare the length of the radiuses. You see, you basically want to check for yourself the distance between the radius of the one circle and the radius of the other circle. You want to obviously check if the distance between here and here, you want to compare that and see if this distance here is equal to the 2 radiuses combined, or this distance here is, let's say, smaller than the 2 radiuses combined or bigger than the 2 radiuses combined. So to make better sense of what I am saying here, let me actually take this here, or rather, let me just take this circle here, copy it, and then paste it over here to showcase scenario number 2. And then let's take this circle again. So copy it, scenario number 2, please paste over there. So you see, this is if these 2 circles touch each other at one point. Let me actually try and change this color here and make it something, appealing. So we are working based on the distance between the 2 circles, as in the centers. So you see here, if the center is here and the center is there, I think a question like this, you can easily find something similar to this on the course on the YouTube channel. Like, I did go through a tutorial where we were determining what you need to do if 2 circles touch or don't touch and all that. So here you can already see that the radius here and the radius here, you see, this is for cases where they touch. So you can label this R1 and label this R2. You see, R1 and R2, you see, this is the radius of the one circle, this is the radius of the one circle. So clearly, if the radius of the one circle plus the radius of the second circle is equal to the distance between A and B, then these circles touch once. You see, with our scenario here, if this is point, let's say A and B as well, why not? If this is point A and this is point B, clearly we know that if you have labeled this R1 and the other portion R2, we can clearly see that between A and B, you see, the distance between A and B is smaller than the radius of the one circle plus the radius of the other circle. You see, it's the distance here from here to there is smaller than these 2 radiuses combined. To make better sense of that, let's have our third scenario here. Let's paste our smaller nyana circle over ISO, and then let's get our big circle ISO. Let's copy this one, paste it somewhere there, paste as a belief. Let's take it there. Let's take this here. So obviously, in a situation where the circles don't touch, I'm sure again you've already figured this out and you're hopefully already working it out, or you've worked it out and you're maybe just using this to double check. Clearly here you can see that this is the radius of the one circle, this is the radius of the other circle, and we could even label this here A and B. So here obviously you have A, here you have B. So here R1 plus R2, you see it is smaller than the distance between A and B. See, these are your three scenarios. You see here circles touch, here circles touch twice, circles touch twice, here circles don't touch at all if you see the distance between their two centers is bigger than the one radius and the other radius. Here you can see the radius between the radius of the one circle plus the radius of the other one. If they're equal to the distance between the centers, then the circles touch once. Here, if you take the radius of the one circle and you plus it to the radius of the other one, if it is bigger than the length between the two centers here, then circles touch twice. This is how you can visualize that. So you can see our question here is easy. The teacher claims that the playing areas will never touch or intersect. Is the teacher's claim correct? If a claim is correct, then we just need to get the two radiuses of the circles, and then we just need to show that the radius, if you add the two radiuses, it will always be smaller than the distance between A and B. So here, me choosing A and B here, it is funny thing is that I think I should just change this from A to B to like C, D or something, just to show that it's an example. Because clearly between these two circles, who knows which one has like the bigger radius or whatever. But maybe I'll change it later. But for now, this is the idea behind what we are going to do. So let's just work out this question. We need, luckily here we have the radius of the one circle, which is just a 2. And then we also have the center for this circle here. You see the center is just 3, coordinate 4. That's the center for this one here. This one you can clearly see we have quite a lot of information. This one we have to get the radius and we have to get the coordinates of the center. So you see we clearly have to put this equation into standard form. And we have worked on getting an equation into standard form. So if you have not learned how to do that yet, then you probably skipped tutorials, Brody. Probably skipped. So, hey, yeah, you can see you don't want to do stuff like that, especially if, say, this topic is a bit shaky for you. Remember, you're going through this course so that you can clean up everything. So if by now you don't know how to put an equation into standard form, it's okay. We're just about to showcase it again. Hopefully you did not like skip anything. So let's just work on getting an equation into standard form one more time. You see, I hope here I didn't give myself too little space because it looks like I did. Anywho, let's see here. Let's paste this here and then let us work on it. Might as well change its color to like something like a green there, so it like pops. Anywho, let's put this into standard form. Putting this into standard form, you see we're just going through what we went through again, so you can even skip through to the end here. I think you probably know what to do here, so you can just mark with a memo and work this out on your own or something. But here we're about to just put an equation into standard form. We said the values of x, put those together, and then the ones with y, put those together, and then take the constant to the other side. And then we said for x and y, identify your values for b. So clearly for the x, we know that the b value here is just a 2. So we're going to add 2 over 2 squared on both sides for the x. And then we're going to add negative 2 over 2 squared on both sides for the y. You see, so simply put here, let's just put a negative 1 squared there, and then for the x, we can just put like a positive 1 there squared. That's what we need to add to our expression on both sides, and then we will just be able to carry on. So let's just do that. There we go. You see, we added the positive 1 squared here, negative 1 squared there, and then we did that for the other side. And then here we already said that all you have to do is to focus on these 3 terms here. These 3, you will just end up with a bracket where this is x. You take this value and then you close the bracket and you square it. That replaces these 3 because you have basically factorized. Same idea here. You're going to have y with this value here, and you're going to square that bracket. That replaces these 3. On the other side, this you're just going to throw in your calculator. You see, this is just 1 plus 1 and then minus 1. That's going to give you a 1. Wow. What a wow. What a wow. Yeah, at least I made circle A much smaller, because you see this one has a smaller radius, because here we can already see that the center, let's see here, center is just -1 coordinate 1, and then the radius is just square root of 1, which is a 1. So anywho, oh, whichever way, let's just carry on. So here we said we need to show that if you add the two radiuses, we need to show that this value is smaller than the distance between A and B. So let us do that. Here, let's label this one A for the sake of this example. Let's label this one B for the sake of this example. So yeah, we need to get the radius here, and then we need to carry on. And I see that I have definitely made these so big that I can't believe I've run out of space. Like, goodness, yassi. Anyways, let's just get ourselves some more space, and then we'll just carry on. We have the radiuses, which is just 1 and a positive 2. So we just need the distance between the two centers using this value here and this coordinate over there. So let's just do that. So AB, we know that the distance of AB, if you use a distance formula, you can write it whichever way you want. I always, for me it's always random. I even start with the x's or y's, it doesn't matter, as long as your values are aligned. You see, y1 here plus y2, or rather that's supposed to be a minus, oopsie, minus x2, and then you square it, and then y1 minus y2, and then you square that as well. There we go. So remember, always minus in here. So here, looking at A and B, you can label these whichever way you feel like. So I'm going to label this one x1, y1, and then I'm going to label this one x2, y2. You see, so here x1 and y1, let's see what that gives us. X1 and y1, that's like -1 minus the positive 3 there. Oops, just be negative there, and then you square it. And then for the y1 is like a +1. That one up there is like a +4. Square this, just double check, so I don't make any funny mistakes. And then obviously you just want to put all this into your calculator. Putting all this into your calculator, let's see what it gives us. It's gonna give us a 5, which is exactly what we want, because we want to show that AB is greater than the two radiuses put together. So let's just do that. And again, remember, within the description there is a link to the tutorial on the channel where we spoke about what you need to do for you to show that circles don't touch and all that shandies. So here we can then show that R1 plus R2, this is clearly just the radius of the one circle, right, which is just what you may call, what is the radius of this circle? It's a 1. The radius of the other one up there, this is just a 2, and then this is clearly just a 3, you see. So here, as a conclusion, we can just say what we have already proven here. So here you can say, therefore R1 plus R2 is clearly smaller than the distance between the centers of the two circles. You see, there we go. You see, therefore circles don't touch. Therefore, let's see here, right at the bottom, therefore circles don't touch. There we go. Fantastic. So this question, it doesn't seem like as though it was crazy at all. It looks like it was okay. Nothing major, nothing funny. Let's move on with the course. So you can see here, going along with the course, this is the idea. We go through certain things like this, and you can see, this is just a 5-mark question. So meaning they didn't expect you to figure stuff out. They just expected you to execute. And this is what you need to know. These 3 scenarios here. These are circles that touch twice. These are ones that touch once. These are ones that don't touch at all. So let's move on within this course. Let's move on. Let's go. We are looking at a B, people. B, yeah. B is quite interesting. Or is it? I haven't even read it. I actually don't know. I think maybe the sketch is what looks interesting. The rest is just like, yo. Yeah, what is going on here? Hey, yeah, ne? So extra. It says here in the diagram below, circle with center A is over here. So a circle where this touches the x-axis and this touches the y-axis. Always remember that the x value here gives you the x value of the center. And then always remember that the y value here, right, gives you the y value of the center, like always. And then it says here, yeah, circle with center A has a radius of 2 units. Okay, well, I guess that settles the center of this circle then. Because if the radius is a 2 here, then it means that this is also a 2, you see. So you have now the center of this circle, 2, coordinate 2. It's not just an assumption, it's a fact, because of the way this is touching the y-axis, it's touching the x-axis. Then it says here, yeah, circle with center A and B of 2 units and touches the x and y axis. It says here BC is a tangent to the quarter circle with center F. Oh, okay, so the circle with center F, it's a portion of that circle. So this is like a big circle. And then they told us that, where is BC? BC is a tangent to it. Wow, okay. So if BC is a tangent, let's use another color. We just can see here we have, like, a 90-degree angle there somewhere. So this here is a tangent. This is going to the radius. So this is 90. I mean, this is going to the center. So it's a radius of that big circle. Then here it says F. No, it says with this. Yeah. It's a tangent to the quarter of a circle or quarter circle with center F. F, they have given us 5 and -1. So let's use that. 5, -1. So automatically this is also going to be -1. Don't forget it. Up here, this is also going to be a 5. We don't know what the y value is. Anyways, let's see. FAB is a straight line. No kidding. But let's see. FAB is one long line. Yes. Then it says the length of AC is square root of 11. Length of AC. Where is AC? Where are you, AC? Where are you? Oh, snap. AC is square root of 11. So I guess that's going to be useful in some point. Whew, wow. Okay. Let's see. All this here, it's just a 6-mark question as it stands. For 6 marks, they said, if the area of the quarter circle is 8 pi units, okay, calculate the perimeter of the rectangular space ABCD. Okay, let's just get a red color. So with all this that they've given us the area of the quarter of the circle and all our random information. So we think, and then now they're asking for the area of this rectangle here. That's quite strange, eh? Yeah, calculate the perimeter. Oh, the perimeter, not the area. Okay, calculate the perimeter of the rectangular space ABCD. Show all workings for 6 marks only. Wow, this question, yeah, it really does look intricate. Like, it looks so intricate, it doesn't even look like it's playing games at all. It looks like it just wants to, like, fight this question. This question legit just wants to fight. But now I'm ready, me. I don't lie. Now I'm ready to fight. I'm ready to fight. It's a 6-mark question anyway. So the one place that you can always start with questions like these, is always start by, like, using the information that you're given. This is square root of 11. So likely you know that this is a right angle triangle. So one more or the other, I mean, Pythagoras might help you at some point in time. We don't know, but you can definitely count on it. Now, a bunch of the other information that we're given, I mean, like, we cannot assume that it is useless, you see. They've given us F, technically they've given us A as well. And to be honest, there's just so much going on. It's just like, yeah, ne? So the best thing you can do for yourself is, you see here, they gave you the area of the quarter circle. So this area here can easily get you the radius. And you may be asking, why is the radius so important? Well, the radius is not that important, but I feel like it's gonna give us 1 foot in the door, because getting 1 foot in the door means that we are able to do a lot. I reckon we get the radius of the circle, because if you get the radius of the circle, yeah, I do think that's useful. Now you may be asking, but why? You keep saying it's useful. You keep saying it's useful. Why is it useful, my guy? Why is it useful? I don't know why it's useful, but I just think it's useful, Like, I really just think it is useful. So let's just get it, because normally if you really don't know what to do in it, just do what your gut tells you. They've given us area here. We're working with circles. It's always good to have the radius of a circle if you're working with circles. So here we know that 8 pi is equal to a quarter of pi r squared. So this is going to be equal to pi r squared over 4. This is like 8 pi, right? And then multiply by 4 on both sides. You're gonna have 24 pi r squared. And then obviously here you can you're trying to solve for r, so you can divide both sides by pi. You're gonna have 24 is equal to r squared, because you divide both sides by pi here. And then square root of 24. Yeah, what is square root of 24? Square root of 24, I don't know me. But then that doesn't look right at all, because this is supposed to be 32, bro. Magangi, you are hungry, you are so hungry. We can see it. So this is like 32 square root of 32. Whew, okay, so we have the radius now of the big circle. So you may be asking, okay, fine, we have the big radius now, and the smaller, oh wow, we can get AF, but why would AF be useful now? Okay, getting AF is useful, because if you have AF, you can say the radius of the big circle minus AF, that will give you BA. That's like, getting you this. And then to get this, you can just use Pythagoras theorem. Or we correct the question. Correct it so hard just because we forced ourselves to get the radius of the big circle. You see, we said the big thing here, FB. Let's just say here, therefore, FB is equal to square root of 32. That's the first phase. The next thing is for us to get AF. AF, we can get it by using, just using normal logic. If this is a 5, and this is like a 2, it means that the distance here is like a 3, you see, because this is 5 on the x-axis. Back here, this is like a 3, so distance here is like a, back here is like a 2, so the distance here is a 3. Furthermore, the x value, the y value up here is a 2, so going down to the x-axis, this is like 2, but then going down here, this is like 1 unit, so this is also a 3, you see, because it's like 2 here and it's like 1 there. Here we said 5 and the x value here is a 2, so this is also a 3. So FB, we can just say here FA squared, using Pythagoras theorem, it is going to be equal to 3 squared plus 3 squared. That's like 9 squared. So here we can say AF is going to be equal to the square root of 9 plus 9. You see, this is like FA is equal to the square root of 18. Fantastic. Okay, so here now we can say AB or BA, therefore AB is equal to FB minus FA, which is equal to square root of 32 minus square root of 18. This, like the best you can do is to just leave it like that. But in your calculator, this is just going to give you square root of 2. This is what AB is, you see. It's just going to give you square root of the 2 over there. I know. It's quite interesting. It's like, what? Really? Yep. It's just going to give you square root of 2. Because this one here, you can split it up into like, you don't just put this into your calculator. You'll get what I got just now. Anyways, so we have AB now, which is just square root of 2, which is good. So AB is equal to CD over there. So this is like square root of 2, right? And then now in that triangle, we can just do the things, I don't know, I'm like wasting space, but I'm not wasting space. Might as well use this space down here. So AB is equal to CD, opposite sides of rectangle. Well, I didn't have to write this, but it's fine. We're writing it already. Opposite sides of rectangle. So therefore this is like Yeah, it's square root of 2, we know. So using this triangle CDA, we can just get the other line that we need. So this is like CD and like A, right? CDA. Where's CDA? CDA. So that's like what's this here? Yeah, you have square root of 2 and square root of 11 in your calculations. So let's do it, man. Square root of 11, square root of 2. You can just label this x, you know. So getting x, we know that square root of 11 squared is equal to square root of 2 squared plus x squared. And then let's see here. Yeah, this one's going to be quite interesting. This here cancels that, right? You're going to have 11. This here cancels that. You're going to have a 2. And then the 2 goes over. You're going to have like a 9. And then you're just going to like square root both sides, you see. So you're going to have square root of 9 here over that. And then you're just going to have x is equal to like 3. What a wow. What a wow. So now you know that the distance here is like a 3. This is like square root of 2. This is a 3. This is like square root of 2, you see. So here you can say perimeter. Oh, look at it. It's the last thing. It's just going to be 6 because it's like these two added together. It's a 6. It's like 3 plus square root of 2 plus another square root of 2. So obviously here this is just going to give you 6 plus 2 square root of 2 because you have 2 of them over there, and then this is just a 6. Nice, man. Oh, this is so good. We are done, and I am hungry and I can go eat. You are probably hungry too. You should go eat. We should all go eat. And I don't know what time you're watching this, in the afternoon, in the morning, in the evening, but whatever time it is, I believe you have put in the work, and it's good, man. It's good. It's all good. It's all good. It's all good. You deserve I don't know, something nice in your life, like good marks, you know, because you've been putting in so much work. And again, you see, you can always hit me up on IG if you need anything. And I recommend that you know, enroll yourself into the courses, because these courses are what is going to change your life. Like legit, I promise you. The courses are going to change your life. So I suggest you enroll yourself. But anyways, it's all good. It's all good. That is that from my side. I will catch you in like the other videos, that are on this channel. And yeah, let me go. Let me go. Cheers. Don't forget to like and subscribe. Obviously, I believe you have gained some value from this. So yeah, you know, do the right thing. You know, do the right thing. You're so good.